We can just keep admitting people when they show up to the waiting room, right? And will you, since Evan and I may not notice, if somebody wants to ask a question, can you make sure we notice? Oh, okay.
Okay, should we get started? Yep, looks like it's 2 minutes past. Okay.
Sure.
Good morning, everyone, or wherever else time it is. It's morning here for me. I'm Evan Suma Rosenberg from the University of Minnesota. Blair, do you want to introduce yourself?
Oh, yes. And I'm Blair McIntyre from Georgia Tech.
And we are presenting the tutorial on web-based VR development and instruction using Babylon.js. This tutorial is intended to be split roughly into 2 sessions. We may or may not have a short break in between them, depending on how we're doing for time. And the timing here might be a little fungible based on how long we spend on particular topics. But here's sort of the rough division. The first half of this tutorial is really going to be focused on developing VR experiences in the web browser. So it will really be aimed towards anyone that wants to learn how to develop VR experiences using web technologies. And the second session is by and large more focused on teaching and instruction, as well as some other topics. This could also be useful for people who are developers, but we kind of had that division there so that you can plan accordingly. As far as our agenda, we'll start out in this first session with just getting started with the tools that we'll be using, Babylon and Typescript. We'll show you how to set up your own development environment, writing your first program using this cool web-based graphics engine called Babylon. We'll cover how to transition that into VR using the new Webxr API. I'll also cover how to import 3D models and assets, and we'll also go over some basic 3D interaction in VR, how you do that, and also how to do remote debugging with both desktop PC-based VR and standalone VR using the Oculus Quest. Blair, do you want to take it up from here?
Sure. So if you haven't if you're not set up to do web programming and you want to follow along, we're going to be, the samples we're using are in GitHub, and we'll go through that. Essentially, to do this kind of development, you need Node.js installed, which includes NPM, the Node Package Manager, which is how a lot of this stuff is powered. If you haven't set it up, I also recommend installing NVM, which is the Node Manager, which exists on lots of platforms. And the reason, so there's 2 reasons. One, you'll find yourself, if you do web programming, needing to switch versions of Node, and if you just install one in the system, that's a pain. Also, if you're on Macs or Linux, anything that's Unix-based, installing into the system directories is sort of always considered bad practice, and NVM installs the node into a subdirectory in your home directory. And then you need some form of Git and a Git client, whatever. I just use the default GitHub desktop and command line. Some sort of text editor. Visual Studio Code is sort of the most popular cross-platform text editor for doing web development, and it has a bunch of plugins that are designed to simplify that. So that's what I think both of us use. Node.js, just Google it. It's nodejs.org is the main platform. Yeah, for all of these, if you literally type Visual Studio Code or Node.js into Google, you'll find them. And part of the reason we didn't have a link is some of it depends on what platform you're on. PC and Mac or Linux have different ways of managing this stuff. So yeah, and as Evan said, we decided to split up the platforms. So I have Evan's got an Oculus Quest, and that actually, the Quest actually ends up being the sort of the linchpin on what made it possible to use these technologies, as we'll talk about in a bit. Okay. You have to change the slides, Evan.
And at minimum, we should say, like, if you don't have Node, if you just download Node.js and install it, it'll take like 3 minutes. And we put this up front now so that if you want to do this, you could be able to download Node and even just grab the GitHub out of our repository that we'll post and be able to follow along in just a few minutes. So if you do want to do that, get started on that.
No, you don't need to know React. Babylon has some integration with React, but it's not required. In fact, I've never used any of the, I've been doing web-based 3D programming for since about 2009, and I've never learned React or Vue or any of those toolkits. I kind of fumble through them, but you don't need to know any of that really, and we'll show you it. Basically, and we'll talk a little bit more about this, but essentially doing web-based 3D, you can, with a little bit of boilerplate and wrappers, you can basically treat it as doing JavaScript, or in our case, TypeScript, and rendering, and ignore almost all the webbiness of the web. But obviously, the advantage of doing this is that you can integrate this stuff into your websites. Okay, any other questions? Oh, there's one. So why are we talking about this? So, I mean, both of us and probably a lot of you have been doing 3D AR, VR programming for a long time, and getting things on devices is kind of a pain, especially when you're working in a lab environment where students may have lots of different devices. If you actually want to distribute something, getting things into app stores is hard, right? I usually give this example at a master's student who had worked at the CDC and wanted to create a game to teach proper condom use to teenagers because she was concerned about STDs. And we built a little iOS game, and we could never get it into an app store, right? Because both Apple and Google won't allow games with sexual content or topics, especially aimed at kids in stores. So it's both the ability to publish what you want, but also the ability to just put it in one place that makes the web great. Works across lots of devices. Pretty much every web browser nowadays supports Webgl, and most of them are getting support for various forms of Webxr, as we'll talk about. And the devices mean that you can have stuff what's referred to as progressive enhancements. So you can have a website that works fine on a phone, a tablet, a desktop, a laptop, and actually adapts to those platforms. And as you'll see in the examples, all of these examples in Babylon by default supports mouse and keyboard interaction on the desktop, touch interaction on tablets, and then when you're in immersive mode, lets you do controllers and so on. The basic wrappers, basic HTML, CSS, which is sort of where I am. I'm at like the assembly language of web programming. Is really all you need to know, and then a programming language that compiles down to JavaScript. And we're not really discussing this, but you can also use non-web programming languages and compile them to WebAssembly. So you can write a bunch of code in C++ or C# or Rust and compile it into a WASM bundle, put it on your website and run it. And people are starting to build game engines and so on for that. So that's a really interesting development that's still going on. And then, of course, as we said, integrate with existing sites. So I have this little slide that I've been showing for years, which is like, yeah, you can actually integrate, D3G, Vue, D3, which is a visualization toolkit, use jQuery, Angular, and so on. If you know and want to integrate with them. So if you've not used 3D on the web, there's sort of this question of how it integrates with the web, right? And I think one of the big questions a lot of people have is, how can it possibly work? Because the web is janky and non-smooth most of the time, right? You can go to websites and they're changing and it, you know, pauses and all of this stuff. Almost all of those behaviors that you're used to are due to changes in the DOM, in the HTML page. Any change, anytime you touch DOM, it forces the browser in the background to do a relayout. And if your website is super complicated, that can take time. So generally speaking, when you're doing 3D or VR, you just avoid touching the DOM and do things in code. You do graphics on the web using WebGL. Now most engines use a WebGL 2, and there's a bunch of new graphics standards that people are pushing, like WebGPU and so on, that try to bring more of the modern graphics libraries to the web. WebGL is basically OpenGL ES3. WebGL 2 adds much more elaborate shader support. WebGPU and such are trying to add, you know, compute shaders and other more modern things. But the basic idea is here in these three boxes. You create a canvas, which is a DOM element. You resize it however you want, using you know, layout on the page, and we'll show you the example we have. Somewhere in your code, you're going to get a graphics context, so WebGL context, WebGL 2 context, and eventually others, which is what I have in that GL variable. And that GL variable has a huge set of properties and methods on it that are essentially, if you've done OpenGL, look a lot like that, right? They're texture management and creating array buffers and all that stuff that you would do if you were doing low-level programming. And I put a link here to webgl2fundamentals.org. It's a really nice website that I use in my classes as well, that sort of leads you through it. It has lots of inline examples. And then the real sort of trick to make it smooth is this thing called request animation frame. So in the web, you can do issue a command called request animation frame with a function, and the web browser will call you back. Essentially, the idea is the next refresh or before the next refresh to execute your code. And then you execute the code, and at the bottom of that, before you leave that function, you call request animation frame again. And that just schedules the next one. And the nice thing about this, or maybe the not nice thing about it, depending on your viewpoint, is that the browser can manage this. So when the load gets high, it can call you less frequently, and so on. So, but generally speaking, if your machine can keep up with what you're doing, it will get called at frame rate. And the frame rate depends on the machine. So if your display is 30 hertz, it will get called at 30 hertz. If you're on a new iPad that has 120 hertz display, you're getting called at 120 hertz. If you're on a Quest, you're getting called at 75 or 90 hertz, and on, right? It really pays attention and calls it at the right speed. So that's the core idea. Now, you'll probably not, unless you're doing very low-level programming, encounter this stuff directly, but this is what all of these engines are built on. Aside from editor and Git is what you need. You need some form of Git client and text editor, and that's kind of all you need. If not, we'll find.
Yeah, technically speaking, you could also just download the whole thing in zip file from GitHub if you don't have a Git client to follow the tutorial. Yeah.
So, that is the thing where Evan and I've been doing this for a little while. So, you know, oh yeah, I forgot you had to install that because I've never thought about it in 10 years. Okay, so how does Webxr fit in with WebGL? So Webxr started out as WebVR back in 2015. A few folks at Mozilla made a demo of this. The core idea behind Webxr, or technically speaking, GitHub is github.com. Link.
I'll take care of it, Blair. I'll put it in chat.
So, thanks, Evan. Sorry, I should let you do that. technically speaking, it's not Webxr, it's the Webxr device API on the web, which is the first of hopefully many cross-platform web APIs for that the W3C Immersive Web Working Group is working on. What Webxr does, the device API does, is expose the platform-specific APIs into the browser in a uniform way across platforms, and that's VR on PC and standalone, AR on head mounts like Magic Leap and HoloLens 2, actually both, and phones, right? And they expose AR as is appropriate for that device. So HoloLens and phones generally only support AR. And the current crop of VR devices generally support VR. Now, obviously, as VR devices that do have more video pass-through become more common, those platform vendors could expose both AR and VR, and your AR apps could just work on those devices. Okay, and the pictures on the right of the slide, that's from a paint program that Mozilla created called aPainter. It's originally in VR on the Vive, and I spent the last 4 years at Mozilla on a very long leave from Georgia Tech, and as one of the things I did with a tablet-based Webxr implementation was port that over to AR, right? And so the same program worked on both. There's a variety of graphics engines. We're not going to go into all of them. 3JS is probably the most popular engine. It's best to think about this as a 3D graphics engine that is at a pretty low level, but is still an object-based abstraction. And is the nice thing about it, it's super popular and widely used, but because the core of 3JS is relatively small, and then you pull in other things as you need them. Creating websites with 3JS, you can actually have a pretty lightweight website if you're not doing anything particularly elaborate. PlayCanvas is sort of at the other end of the spectrum. It's has an online IDE that looks very similar to Unity. You use it through that IDE on their website, so it requires you to do. Oh, what's going on with my mic, Evan?
Oh, it's breaking up pretty bad at times, but so you might want to debug that when I take over.
Okay. I'll just drop the RTX voice stuff. My GPU is probably not happy. Let me just turn that off right now, and you can tell me if it works, if it gets better. Come on, there we go. Okay, does that sound better aside from a little background noise?
Yes, much
better. Yeah, okay. Yeah, apparently even with my 2080 Super, it can't handle it. Lovely. So anyway, PlayCanvas at the other extreme. Their engine is actually open sourced underneath, and I had my students do a PlayCanvas in the browser experience and then port it over to their ECS-based engine, which had like one-to-one functionality, but it doesn't give you any of the niceness of the editor. Okay. You know, there's even more things you can do. So there's people are working and have been working on declarative engines to integrate 3D into the actual HTML DOM. So A-Frame is pretty popular. It's built on top of 3JS. A lot of the researchers are probably familiar with X3D and X3 DOM. They're working, I'm told, on getting Webxr support in the next version of X3D. Okay. Babylon, and we'll talk a little bit more about why why we use it for teaching, but it's basically an object inheritance like 3JS and a lot of other engines. It's open source, it's written in TypeScript, and I said how 3JS is very low level. Babylon is sort of at a slightly higher level in that it's more opinionated. It includes more features cleanly into the basic engine, so that you have to do less work to get stuff, to get things like various effects and that stuff. But on the other hand, it's harder to switch away to other things when you need, potentially. It's a good 3D engine. It also includes a pretty extensive 2D and 3D GUI system. Microsoft officially supports it. It started as open source, but they liked it, so they started paying people to work on it. And recently they released something called Babylon Native, which is akin to React Native. It may actually use it, but that lets you take Babylon apps and build Babylon web pages and build apps across phones and headsets and so on. So those are all sort of nice things about it. Okay. Quickly, TypeScript, we keep talking about it. TypeScript is a object-oriented extension. It's a strongly typed extension to JavaScript. So it's open source, also actually supported by Microsoft, and it adds static typing to JavaScript. Every JavaScript program is a valid TypeScript program, and when you compile TypeScript to JavaScript, it outputs JavaScript that looks very similar to the TypeScript code, with some syntactic jank to deal with some of the typing, but the strong typing is very pervasive. It's strongly integrated with Visual Studio Code, so that you get, if you're used to programming on traditional IDEs like Visual Studio or Xcode, you get full IntelliSense and completion and highlighting for syntax errors, the ability to do multi-file replacement of properties that take into account, that aren't just text-based, that actually are based on the syntax and object system. So it's really, if you are a fan of strong typing, it's really good. And I put the URL to the language there. Okay, are you taking back over now, or me? You?
I believe I'm taking over now.
Yeah.
Okay. So thanks. Your mic was better, but it still did have a little bit of breaking up. I'm not sure if
that's probably my crappy internet.
Okay. All right. And also by request in the Discord channel, I have posted links to both the GitHub and the slides for session 1. If you want to follow along with our slides, I'll post the slides for session 2 when we get there as well. Okay. So now I'll take over from here. So one of the things that's also very nice with Babylon is the extensive documentation in the community. Blair was doing this before me, and then I really started getting into this when I had to teach my VR class remotely last fall. And so I was starting from basically scratch. And there's basically a tutorial on Babylon for pretty much everything that you could think you need to do. So it was useful for me and both students. And so this is really nice and is pretty extensive. The other thing, and this is another nice feature, is that a lot of the documentation links to what they call the Babylon playground. And you can actually try this live right now. So if you go to babylonjs.com, and you scroll down here and you see there's a playground link. That jumps you right directly into a live programming environment. And many of the documentation and examples will have links into Babylon Playground for the actual example that goes along with the code, and you can do it live. And so this is a live programming environment within the browser. You can see I can move my camera around, and I can code live. It has both TypeScript and JavaScript tabs, so I'll switch over to the TypeScript tab. You can see if I want to make the scene darker and I want to make this sphere, let's see, move upwards, I can just do that live and then hit the play button, and the scene updates. So this is not something that I typically use in the context of developing like a full VR application, but for doing small like tests or tweaking or showing students examples or just being able to try hacky solutions to things without necessarily messing up your code, the playground is a really nice resource. The link, someone just asked me for the link for Babylon, just Google it, but it's babylonjs.com. So you just go there and you can get to that. And the playground, I'm putting in the Discord by request. That's the link to the playground in the Discord as well. But yeah, this stuff is all easily found on the web.
So Evan,
Yep.
another nice thing about the playground is that there's vast numbers of things other people have created there. So if you want to see how to use a specific object or method, I just go there and I search for it. Like, how do I use this version of lighting? And you'll find like a whole bunch of projects, anything that uses that object. Many of them are super old and jank and maybe broken because the person never got it working. But at least it gives you this sort of community resource of huge code samples.
Yeah, you can see there's a save and load functionality here. So I can actually save this, create a persistent link to whatever my playground code was, and then share that to my students, and they can just load it up with the link. So quite useful. Okay, so this is, I think we're back to you, Blair.
Yay, let's see. I actually switched my mic completely away from NVIDIA stuff. You can hear me, right? So we'll see if that works better. Okay, yeah. So I will now.
Yeah, I have to kill my screen share and you have to do it, right?
Yeah.
Okay. So 1 second, we're switching screen shares.
And given how great my mic is working, I'm sure this will be awesome. Are you seeing my screen?
Yes.
Okay. With a little windowed projector title bar, make sure I'm sharing the right thing.
Yes.
Okay, cool. Okay, so right now you see my Mac. So this is, Evan shared the link to this. If you haven't done much web-based programming with these tools, many of you have probably used GitHub anyway, but so I'm going to, sorry, let me go back. The example we have in here in this project template, essentially the same program that gets created by default that Evan just showed you from the Babylon playground. So I'm gonna go here. I actually deleted it from my local computer. I'm gonna see if I can get it all done. So I use GitHub Desktop as my sort of main Git client. The nice reason for doing this is that it sets up all the SSH links or SSH key exchange and basically gets everything working correctly for you. So this thing, give it a local path here. I'm just going to choose the default since I was already using the right directory. So I'll clone it. It opened up. So it opened up GitHub Desktop when I clicked on the download button there. So now I've got it. One of the nice things here, you can go and I can open in the Finder, open the terminal. You probably can't read these because it's so small. I can also, it has a link for Visual Studio Code. So I can just go ahead and open it directly in Visual Studio Code and I get my project. So I'm going to do just a little tour of how this thing all fits together. Let me CD to the right directory, project template. And how we get stuff working. So this is the project that was downloaded. I'll just touch on everything that's here. So there's 2 ignore files, ESLint ignore. So the linter, if you use it, won't look in those directories. Similarly, git ignore. We don't want to, there's a bunch of things we don't want to upload back into Git if we use them. So npm will install everything here. It'll create a package lock that you don't want back up, and so on. Sometimes if things crash, you'll get a debug thing. And when we build the resulting project, we put it in the dist directory. We don't want to send that back up, although you may want to. just because Evan, when he was creating it, wanted a favicon on his websites. So we have, there's our HTML, but I'll get back to that. So we've included here a README that you actually see on the website down here. So this is in the readme.md, and it shows you how to do the various setup. So there's a configurator for TypeScript. I said TypeScript, any valid JavaScript is valid TypeScript. That has a big asterisk beside it because you have to actually tell TypeScript to sort of be loosey-goosey and accept untyped code. Generally, for teaching and for my own work, I have a whole bunch of stuff turned on in TypeScript that prevents normal JavaScript from being valid TypeScript. Things like requiring typing, not allowing implicit returns, just a bunch of stuff. And you can see that when you go and look at and learn TypeScript. But we've basically got it set up to be super restrictive and really find all errors for you. I list my one TypeScript file here so it knows where it is. You can just list directories and things as well. If you don't have a files, it'll look in your entire project for any TypeScript file, which is probably maybe not what you want. The final thing is how do you actually compile, run, and test? So on the web, there are a bunch of ways of bundling up code into a single file to make a JavaScript file. So when you think about React or 3JS or jQuery or any of these JavaScript libraries you might have included, it's one thing. But if you go and look at the source for it, there's hundreds or thousands of files. So there's programs, there's a bunch of different ways of packing all that stuff together. Programs like Webpack, Babel, and others. For this, we're using Webpack because it was a relatively clean solution for using TypeScript and Babylon together. So the idea here is when we run it in dev mode, it will create a dev server for us, run it locally, and allow us to connect to it. So it'll build the code and then run a web server on your local machine. And we have a second version of production, which just outputs, doesn't run the web server, it just outputs the compiled and minified stuff into a JavaScript. And we'll show you both of those. And then there's some common options that both of these include. So how do these get executed? So the core of any npm node/npm setup is this package.json, which you'll see it a lot at the top of a lot of GitHub projects. So in terms of terminology, Node is a JavaScript execution engine that, and I should make sure this is visible just so in case I need something. No, I don't even know where my thing is. I'll trust you to tell me if I need anything. I'm not seeing, Evan, right now, I'm just not seeing the chat or anything. So Node is a thing written to run JavaScript. It was designed to do server-side JavaScript. And so it's used in a lot of production environments. And it has all kinds of features like load that make it possible to do load balancing and stuff like that. But its key claim to fame is that you can essentially use JavaScript on both the client and the server, share things, and there's a bunch of sort of nice things you get with that. NPM is the Node package manager. So you can go to, I think it's npm.org, and tons and tons of packages, both for web dev and not web dev, are shipped there. And it has versions and all this stuff and links back to the source. That is what we're using Node for here primarily. So all of these dependencies are things that exist on npm.org. So they are a version of Babylon. We want version 4.2 or later. We actually pull down the entire TypeScript compiler. Instead of compiling it globally, it just gets installed as a development dependency. So you know that you're using, for any given package, the right version of the language, the Webpack, and so on, okay? And so what you do, so I'm here and I've got this. So the first thing you tend to do is run npm install, and it's going to go through these dependencies, find all of the things they depend on, pull them down, and install them in a directory called node modules in your thing. And depending on the size of your project, this can take a little while, okay? Often there are lots of errors or warnings. Come on, finish. So this eventually finishes, and you'll see if I do a little refresh here, I now have this node modules directory, and if I open it, I will see a few packages. Lots of packages, okay, including, so like I said, so there's a version of TypeScript in here, down here. There's and then up here I have my Babylon install, which pulls down Babylon. So this finished. Now to do various things, you can define scripts, and you run them using npm run. And so I said that we had two ways of building things. We could either build the production JavaScript website, the website in JavaScript, which we would do with npm run build, or we could start a development server, okay? So let's actually just do the server. So I'll run npm run start. We've got it configured to automatically open up a web browser window, and it takes a bit. You can go and reconfigure this stuff to be a bit more efficient and fast. We're just doing a simple version that bundles everything into one JavaScript file. But here is what should look very familiar, right? The thing that Evan was showing you. I'm going to go back and look at the code now. So it looks this is the same program that Evan was running. Let me see. So this is the web page. So people were asking about the web and what do you have to know? This is our entire project. It's got a head, some simple styles. We're making the canvas, fill the page, making the body fill the page, including this jQuery, since it's used in this system. Actually, I don't even know if we need it, but and then we have our canvas, which has an ID render canvas and has a touch action. Okay, when Webpack runs, the way that we're running it, it actually builds a JavaScript file and injects in your HTML an include statement for it. So if I go, and I'll show you that in a second when I talk about debugging. So in here, our TypeScript is this is the equivalent of what Evan did. Now, there's a few things that are different from the Babylon playground. So the Babylon playground, the first thing it does is include the all of Babylon into the playground and make it available, so that in the playground, if you go look at this program, you will see things like, actually, I can just pull it up. Is it playground? Yeah, I'll just pull up some playground. I don't even know what this is for. Oh, this is for our thing later. So you'll see most things prepended with Babylon dot, because when you include a JavaScript, include the library as JavaScript, it prepends everything in its own namespace, much like if you're using any other web library like jQuery or Vue or something. But aside from that little persnickety thing, the code here is very similar. And the code in this case will be down in our create scene. So here our universal camera does not have Babylon dot. Here the camera we're using does. Okay, and actually let me make that bigger. Okay, so that's sort of a key difference that I just wanted to point out in case you go and try to use this. Okay, so briefly, I don't want to go through it in gory detail. We're using what's referred to as ES6 imports. So the JavaScript is technically called ECMAScript. The most recent version of JavaScript includes proper modules, so you can actually break your code apart into modules and not have it bundled. A TypeScript sort of mirrors that. So here, the reason we don't have to prepend everything with Babylon dot is we include what we want. So I pointed at the universal camera before. So we include the universal camera class from this file and import it. And you could even import it as something if you wanted. And so now we can use it. So this does mean that we need to include everything we want to use using this model, which probably feels familiar from a lot of languages. There are a few things we need to include because they have side effects that won't work, which is an unfortunate artifact of Babylon's move from their include the full .js file to breaking things apart in modules, and they're working on cleaning some of this up over time. But aside from that, a typical JavaScript web program will have this feature or have this structure. We define a class for a single language thing. So I define everything that we're doing in a class. If I scroll down to the bottom, my class ends there. This JavaScript will just execute. So I create a global instance of the class and then run it. Okay. So when I build the system, it goes, what it's doing is going and finding all of this in Babylon and tree shaking. So finding everything that is required to make all of this work. So all of the bits of Babylon we need, bundling it together into one large JavaScript file, loading it, and it loads synchronously and executes synchronously. So the last thing that happens when I load the JavaScript is it runs the start method. The start method up here in our class, so we have a constructor that goes and finds our canvas, creates an instance of the engine, creates a scene for us. The start method calls create scene, which is down here, and then runs the render loop. So this render loop is Babylon's equivalent of that Webgl loop that I showed earlier. So this runs, and what we're doing is we're updating our scene every frame. So we defined an update method. So we could, for example, do something every frame if we wanted, but that's just something put in here for structure for the students. And then call render. So basically this loop just runs the loop and renders over and over and over. We put a resize handler in so that when you resize the window, it calls the engine's resize event, which takes care of changing the camera and all this depending on how you've defined it. And this is one-to-one what's in the default playground. Create a camera, point the camera at something. This is a universal camera. Why am I, oops. So I can use the mouse to move around. I think I can use the keyboard to move, yeah. So I'm using the arrow keys. And we create a hemispherical light, create a sphere, create a ground plane. And then here we added this debug layer, which is what you see here. So this is kind of really nice thing you can include in Babylon programs. I can actually go here and look at the things as they are. So I could, as Evan showed, I could, in the playground, I could actually go here and change the height of things, move them up and down and so on. Change material. So I could go down here, change my diffuse material, and I could do this live. Now this isn't being saved. This is just changing it in the code. But if you want to sort of experiment with things and positions of stuff and materials and other properties, everything in your Babylon scene is visible here dynamically. Okay. So and you can also just close these if you want. Okay. So that's the basic Babylon setup. And one of the really nice things of this setup is that, like I said, we've got IntelliSense, right? So I go over something, I can see its properties. If let's say I was typing this, and I typed comma, it's going to show me what's possible. And my property right now I need is a Boolean, and I actually don't remember what it was, so I'm just going to undo. It was true, right? Was it true? Yeah, true. So so I could start typing true, and when it's a valid, Boolean, and I'm done. And so, same for all the other properties. So it's quite nice in that way. But the real power for me comes from the fact that I can poke into the source. So if I bring up the menu click, I can go to the definition for something, go to its type definition, go to various implementations. So here, and if I hold down the Option key on the Mac or the Command key, it'll actually turn the object into a link. And I click on it, and now I'm actually at the class definition, and I can look through and see everything. And where is this exists? Well, in node modules, inside Babylon.js, core, lights, I see, and I'm going to make this a little bigger. I don't think that's big enough. Yeah. I see I've been moved into hemisphere lights.d.ts. So all of Babylon is written in TypeScript. When you compile TypeScript to JavaScript, it creates two files for each TypeScript file: a type definition file, the .dts files, and which correspond to the TypeScript definitions, and a JavaScript file which you can load and run, which looks very similar, but is now pure JavaScript. And this is JavaScript Es6 imports, so it points over to where the actual files are for each of these things. A little bit of weirdness to convert TypeScript classes into JavaScript classes, but you can now go and actually look at the implementation of everything and see how stuff works and follow it around, right? So anyway, so I really love this, and I really encourage the students and such to use it as well, because it helps you sort of demystify things. And when you can't figure out how to do something, you get the advantage of just being able to go look at the source. So yeah, so if I save my lack of change, Webpack detects it, recompiles, and when it's finished, I can go and refresh it on the web and get my thing back. Okay. Okay, so that's just the basic thing. I can't see the slides, Evan. So what's the next slide?
The next slide after this was the try it with your ngrok.
Yes. Okay. I'll pull that up. Actually, I have the slides here, so I will. Yeah, so I will pop up. So so back to the next slide here is there's this question of, okay, how do I actually do stuff across multiple devices? So like with standalone display or in class, right? So let's say I was live coding in class and I want the students to do it. So there's this thing that I use called ngrok, which I will go to an ngrok website. Ngrok, make sure it's big enough. Yeah, so what ngrok does is, this is not big enough, is let you run a little program locally that that bridges through to a local server. So here, oops, let me switch back to the Mac. Here, so I'm running ngrok here, and I'm seeing all these OKs because a bunch of you were actually doing this. And I hope my internet can handle it, and my video and stuff isn't getting trashed. So when you'll notice here that the URL for this is mymachine:8080, because Webpack runs a local server on 8080, on port 8080, as opposed to the default 80. What ngrok does is somewhere up in the cloud, I am using vrblair. And I set up vrblair as my domain, .ngrok.io, and it is poking through to both to my localhost 8080, and it's doing it for both HTTP and HTTPS. This is important because Webxr requires that you use HTTPS. There's a variety of web APIs that will only work over encrypted connections for privacy and security reasons. Okay, so I will switch over to is my video and everything still working okay with people doing this, Evan?
Yep. Although I don't think the link is loading for many, it might be overwhelming your internet connection.
Yeah.
I have fiber, so when we do the one on
Yeah.
my computer, hopefully it'll keep
So
up.
Evan's he'll put his in. Evan's got gig up, gig down. I'm still on DSL, so I'm 7 megabits up. So it's a wonder, this works at all. So stop using mine because it'll basically change Blair to Evan, vrevan.ngrok.io instead of vrblair, and it should probably work a lot better.
I need to bring mine up. I'm not running.
Yeah. Okay. So oh yeah. So over on my PC, I'm going to reload. So now on my PC, I can actually load it, and it's actually probably going to be just as slow because the one downside of using ngrok, which is probably hopefully obvious, is that to go from my PC to my Mac, which are connected by a gigabit switch, it's going out to ngrok's website and back down. So can people stop trying to use mine for right now, just so that we eventually load locally? And so this big bundle of web stuff is fairly like I said, unoptimized. So it's a few megabytes for all of the Babylon stuff packed together, which over my crappy internet connection is pretty slow. Okay, I'm just gonna break everyone by killing it and then starting it again, which will let me do it before everyone else does it. Okay. So come on, PC. No. Okay. I'm going to take my other approach.
Mine is up now. Mine was still compiling. So if you go to vrevan.ngrok.io, which I linked to in both the chat and the Discord, you can now, I'm seeing a bunch of requests come through. You should be able to load it.
Okay. I'm going to change mine to a different ngrok just to flush all the rando stuff. So I'm just going to reload it again to make sure it worked. So let me just load it up. Well, we saw it load and you're seeing it load. So this is how I communicate. This is how Evan communicates with the Quest and how my students do Quest development or one way. And now I've got this on running on my PC, same thing. Okay. So so that is super useful. And the real kicker for this is that it means that on a Quest or even across computers, as you know, if I'm at Georgia Tech and my laptop gets a new IP address over and over and over, then I don't have to like figure out and save the IP address for the new URL. I can just always go to the same URL. So it makes mobile development super simple. It means you have valid security certs, so you don't have these warnings coming up all the time that your certs are invalid if you're running a fake secure server locally, and so on. So it's super useful. Okay, so the next thing that we wanted to do was building redistributable code, and this will be quick. I mentioned this before. To compile, so you'll see in my directory, I do not have a dist yet. If I run npm run build, which was the other script in my package JSON, which runs the webpack command with our production script, it's now building it again, but it's building it for distribution. And I don't think it's created anything yet, but it'll just take a second. And this is useful, obviously, if you don't want to have to run a node server, right? So if I want to put this on my website or submit a class project, whatever, being able to wrap everything up into a static HTML website so that it can just be put anywhere is obviously a necessary thing. And there, that built. So if I refresh here, let me actually, it's going to be up above node modules, of course. So it created this dist directory, and it created two things. So it created an index.html, which is a little bit stripped. So it's a little more ugly, but you can see here, before I had my canvas. So if I compare this to my index.html, down at the bottom, the last two things are the canvas, and that's all my body had. The built one has the canvas, and then it injects this script tag right below it for JS Babylon bundle.js, and it built it over here. So it built this bundle, which is this massive compressed thing, which you can't possibly make sense of, and then a source map, which basically indexes from this compressed JS over to the original source files. And this turns out to be super useful because, and I'll flip back over here. So you can take that, before I flip over, you can take that and copy this dist directory anywhere on the web, and it'll work, because the only thing this index refers to is this one external JavaScript file on jQuery's website and the local Babylon bundle, and that's everything. And so this will run, it'll look exactly the same. Okay. So let me flip back over. So why is the map important? For debugging. Okay, so if I go over here, if you've never done any web programming, the question now that might be occurring to you is, okay, that's great. What happens if there's errors? So the web has, I'm using Microsoft Edge, and Chrome, it's basically Chromium based. So Chrome would have the exact same set of menus. Safari and Firefox appear slightly differently, but somehow you can pull up the developer tools. I've got it set to open a separate window. So that's a little big. Sorry, Control minus. Okay, so here is my website. So this is the developer tools, and I can see a bunch of things. Here's my console, which a bunch of random errors and other things printed out. I can actually, I don't care about that. I can actually see my website, and when I mouse over it, I can see the various things, and I can see my oh yeah, I'm gonna close all this. So where is Scene Explorer? So the Scene Explorer injected a bunch of junk into it, but here is my canvas, which I'm just gonna close this and close this. So when I close those, they get pulled out. So this is like my original thing, right? So I got my canvas, which is full screen, my body is full screen, and there's my bundle. The nice thing in the Explorer is I can actually go in and change things. You know, I could change this to 50%. Okay, maybe not 150%. 50%. So now my width is 50%. My body is the full width, but my canvas is not. So I will change that back. And so you can, much like, come on, why aren't you letting me change out? What the heck? Oh, I have to actually click over here and then edit and then do 100%. Okay. Okay. But the real power comes from going over to the source thing, where you can actually do debugging. So here we can see the source for our main index, our top level is here. And you start wondering, you should be asking, or maybe are thinking, if everything was packed up in that one file, how does it find this? So all of that stuff that got packed up is down in here. This dot and dot directories are actually, but in particular the dot directory corresponds to all of the things in my project that got pulled in. So I have source index.ts, so it's available there. And then I have all of the stuff that actually got pulled in from my node modules, or actually I guess only part of it here because the other stuff, it's always confusing. The other node modules are not there. Make me look bad. Where did it go? Is it under Webpack? This happens sometimes. It assembles them in weird places. Is it in dot dot? Oh, come on. Oh, dot dot. Dot dot? No. Should be in node modules. Where is Babylon? Oh, here? No. Webpack. Sorry. I went through and did this last night and then promptly forgot how, where I found it. Lib, inspector, Babylon. Oh, maybe here. No. Oh, well, I'll do it this way. We'll just find it the easy way. So this is a full debugger. So I can go through, this is running, and I can set breakpoints. So the one thing I know that's happening is this, engine resize. So now, hello, why is that not stopped? Oh, I've got breakpoints disabled. There we go. Is that stopped? No. Okay. Fine. I don't know why that didn't work. Okay, give me a second. And I clicked on a very large file. Sorry, shouldn't have clicked on a multi-megabyte JavaScript file in the debugger because now it's loading it. So, so you can do full debugging. I'll actually go on because I'm going to come back here on the next slide, on the next thing. Okay, so the last thing, so the other side of this that we want to show you is how to do XR. So I've already got a project loaded. So there is a second project in our directory called the Webxr template. If I go over to here, where's my top level Webxr GitHub? Okay. So if I go up to the top level, we've got 3 projects. The second one is this Webxr template, which is a relatively simple Webxr program that illustrates sort of how to set up Webxr instead of just desktop 3D. Okay. So I've already pulled it down, so I don't need to do that. I've already run npm install, so I have my node modules and so on. So I just want to quickly go through what's different about this from the other things. So there's a bunch of extra stuff in here because this program is slightly different. It's got a little UI and so on in here, but we still have our includes. There's a few other things like this Webxr feature manager that I've included. You'll notice some of these includes are grayed out. That's because they are not actually used in this program, but I left them in for my own convenience and because if you want to do pointer types and so on, you will need them. But so far, this is all the same. We find our canvas, we create an engine and scene. Our start method is still basically doing the same thing. This difference is here. So up at the top, I created a different scene. We have a sphere or an icosahedron, a directional light now instead of a universal light, a different camera, an arc rotate camera. This, and then a hack. So the default Webxr, the Webxr Babylon infrastructure includes this way to create a default environment right here, the create default environment thing, which is nice. It creates a ground plane and a sphere, and it's fine for sort of simple tests. But it does a bunch of clever things that can get in your way. And in particular, it figures out the bounding volume of all the content and makes the floor just below the content, puts the skybox around the content. But if you actually want to be in VR, you'd like the floor to be on the floor. So I created a teeny tiny sphere, put it at y = 0, and so that my floor will be just below that. So that's why that's there. But now, so I create this default environment, enable shadows being cast on the ground, and now I'm going to create shadows. So this shows how Babylon Shadow Generator works, and I'm having the icosphere up above, casting shadows onto the scene, and shadows again are cast on the ground plane. And now I initialize Webxr. So deep down inside to initialize Webxr, you make a call, which basically is where you say, what are the proper, does this browser support Webxr? Does it support the requirements I have? So you can say, I want VR, or I want AR, or I want an inline, so just on the desktop session. So internally, there's some steps you go through, and the immersive web community groups, web pages, and so on can show you that. Most people will never do that. So Babylon wraps it all up in a few commands. So first, they create a default XR experience helper, which creates some controls, creates some controllers. It actually has a website, the Webxr community does, where it'll go and pull down models of your controllers depending on what they are, so you don't have to worry about that. It'll give you the correct models, but it creates a VR set of VR controls essentially, and in this case uses floor meshes, so we're using our ground plane for teleporting and walking, and then and it also initializes Webxr. So this is an asynchronous command, because this can take a while. And in particular, the first time you run it, your browser will ask you if you want to allow them to run Webxr. So this could take an arbitrary amount of time to run, which is why so it's in the web parlance, this returns a promise. A promise is a small object that that is a handle that you can use to check if some asynchronous thing like uploading to the web or doing a HTTP call is finished, or wait for it to finish. So this is basically going to stop all progress until this potentially asynchronous long-running thing finishes. Once that's done, I just get the features and print them out just for fun, just to see what features this device has, print it out to the console. And then everything else is pretty similar, right? We added, I added a little observable here, or I didn't. This is taken from a Babylon webpage that rotates the sphere every frame. So right before rendering, it rotates the sphere a bit each frame. And then the rest of this is actually for the GUI, which I'm not going to go through, except to say that there's essentially two kinds of GUIs, 2D and 3D. In Babylon, on the desktop, on flat screens, 2D GUIs can be put on the screen flat, and they have some convenience functions for that. Otherwise, their GUIs are basically rendered into dynamic textures. So here we create a plane, create a dynamic texture, and put this stack panel, which is a GUI box into which you can put things onto that plane. We create a little text box that says color GUI, do some alignment. If you've done any UI toolkit, this stuff will all look familiar. Create a color picker, which has its colors defined down below here. Add that to the panel, and then finish. Okay, so I'm going to run that.
Well, Blair is running that. This is also now live on the vrevan.ngrok.io link that I posted in chat and in Discord. So you can also load it on your end by going to that link.
You'll probably get it before me. Okay, so I'm going to go over to my PC and reload. Okay. So then I'll switch back over to my PC. Okay, so that's finishing loading. Oh, Lord, sorry, I'm in the wrong directory. Okay, so now I will wake up my headsets. Which will cause all of my screens to go wanky because Windows Mixed Reality adds a bunch of displays to my display, which is irritating. I also resized it. Thank you for that. Okay. Load, load, load. Okay, so here's the thing. We have our icosahedron, we have our GUI, and we have this rotating sphere. You can see this ground plane with a shadow cast on it, and then there's this sort of fuzzy skybox. Again, the inspector lets you look at everything. I'm just going to ignore that. But now, because Webxr exists on this device, it detected the Webxr capabilities in the DOM or in the browser. It puts this little browser thing up, and if I click on it, oh, actually, first let me start. So I'm in Windows Mixed Reality, as you can see. When I click on it, I now have this allow thing. So this is where that thing is waiting, right? And the user gets to choose if you're going to allow VR. Because there's privacy security implications if you can let web pages just access devices like head trackers and hand trackers and so on. So I hit it. Windows Mixed Reality is saying, ooh, we're going to go into a thing. I will put this up askew on my head, and we will see it. I will pick up my controllers and turn them on. Well, I may as well just do this. Why not? Okay. And I have, hopefully you can see in that tiny window, two things that are exact replicas of my controllers. I can move with the teleporter. I have raise, and I can click on the GUI to change colors, and so on. And it looks just snazzy on my beautiful Reverb G2. Okay, so I'll push that up. And I will do this. Oh, what is it? Windows Y. Okay, get the keyboard back. Okay, so oh, I hit Windows. Lord, go away. Okay. Well, okay, so do Windows Y again. Windows, thank you. Windows Y again. Okay. So this stays up there so that my display doesn't go to sleep. And now I can do the same thing as before, right? So I can go in. You can see it still moving slowly because of things. So if I go into developer tools, hopefully this will work this time. The way I expect, as it loads everything. It'll take a little bit. Just wait. Why are you running so slowly? Okay. So you can actually see here, for example, I printed out the Webxr features. So this browser plus Babylon expose a bunch of features, which is nice, that can be used. So Webxr is a progressive thing where the basics are required, but then a bunch of additional things like, say, plane tracking, which might only exist on AR, only exists in AR. So we can see, I'm going to make this a little bit smaller. So you can still see I'm working. So now I go over to My sources, again. Oh, why is the browser going so slow? Apparently, I did something bad. Don't need to be like that. And there's a bunch of other things here in the browser, like you can see performance graphs, memory thing. You can actually look at what's being downloaded on the network, so on. So I am not sure why this is being so slow. Normally it isn't. Give it a second. We might just move on and do debugging later if we have chance. What time is it? Evan, do you want to?
Yeah.
I'm going to restart my browser. I don't know why it's. Oh, okay.
Yeah, we might want to just because of time.
Okay. Yeah. Okay. So you could go in. All I was going to show you is you can go into the thing, set a breakpoint in that break loop, and then you can go and explore all the code, do all the usual stuff with variables and hoo-ha to standard debugging. So the web is the web browsers, and different web browsers have different debuggers, so you can sort of pick well, you can pick the one you want on the desktop. Okay, take it back, Evan. Let me unshare my screen. Okay.
Okay, I should have taken that back. Let me make sure my chat window is open on the other screen. Okay, great. All right, so let's go ahead. So one thing that you may want to do is you may want to try out things on, try out this cool Webxr stuff right now. And if you opened up that ngrok link, all you saw was sort of, you wouldn't see that little headset icon in the bottom right of the screen, which you see here, which you would click on to enter the immersive mode. Now, I don't currently have a headset connected to my screen, and yet I can enter into immersive VR mode. And there's a fun, cool way that I can do that. There is actually a Webxr emulator that was developed by Mozilla that's a browser extension. It's available on both Chrome and Firefox. And it's very convenient because it allows you to emulate having a headset connected. So right now, if you want to do this, you can actually, so I linked the GitHub there because it's open source, but I'll put right now in Discord and chat a link to the Chrome extension. So you could actually install that browser extension right into your browser right now if you want, and then you'd be able to go into the actual immersive mode. One thing to note is that if you went into this, and I'll open it up in a second on my end to show you, but the default Webxr emulator developed by Mozilla only supports both headsets and controllers, but only two buttons. Basically what they call the squeeze button, which is your grip button, and the trigger. So none of the thumbsticks or other buttons on the Oculus Quest were capable. So I did what any reasonable developer would do, and I forked the official Webxr emulator and added all the missing functionality for the Oculus Quest. So this is probably not something you can do right now because you would need to go to my GitHub, download that package, and then you actually have to go into developer mode in your browser's extensions page to install it, and you can read about that on the GitHub. But basically what you will see is a screenshot here. I can open it up for you right now. If I open this up, you can see if I just click around, I'm just looking at the scene that Blair had and without VR. But if I click this, and then if I go into the developer console in my browser, and I'm using Brave, which is another Chromium-based browser, so it's the same as Chrome. I use Control-Shift-I is, I believe, the shortcut for that. And then this pops up, the DevTools. But because I have the Webxr emulator installed, I just click the Webxr tab, and now I have this. Notice that when I did that, two controllers popped up. This basically says I think I have an Oculus Quest here. I can move it forward and back. I can move it all the way down to the ground, test where the ground is. You can see the position there drop down to 0. I can reset, jumps back. can move my controllers around. If I aim the controller kind of at the GUI and then I press the trigger button, you can see I holding the trigger button down, turning it out, and you can see all these buttons are toggleable. The only one that actually works in this particular example is the trigger button, but you can see I can try to set it to a different color and it works. So this is great for students. This is great for developing stuff just like on your own before you want to go jump into the put on the headset. So you don't have to constantly take the headset on and off all the time. So I really found it to be very, very convenient. Yeah, someone in the Discord said this is the coolest thing. Yeah, the Webxr emulator is fantastic. I wish they had this kind of stuff for like Unity and all the other toolkits. So yeah, you can get that. You can get the official one for only 2 buttons, or you can go to my GitHub Labs GitHub page and get the forked version, which has all controller functionality. But let's actually now talk about actually running on the Oculus Quest. So there are options to connect from the Quest. You can do what we did, which is run ngrok, which basically creates this tunnel into your local machine, and then send that out. Blair sends that out to his students, and they can connect. You can also just do that and then bookmark that IP in your Oculus browser. So if you go into the Quest, you can actually just do that right there. Or you can actually just skip ngrok if you have a static local IP address and they're on their same local network, like your home's Wi-Fi network. You can then just use your local IP address and load that. And then you can also direct connect using a USB cable, and that will work as well. I'm not going to go through all the remote debugging and screen sharing instructions, but on my course website, you can find links to which are all open source. You can find all the documentation and to do that. So real quick, I will just I'm gonna, just in the interest of time, I will do the next thing, which is importing art assets. And then we will show you that running live on the Oculus Quest with the screen share. And then you will all, if you have a Quest handy or a headset hooked up, you can then open up that link and load it yourself. But let's skip that for now and go straight to art assets, and then we'll do that all in one in the last one. So this is the final one to check out. This is the last. This is the Webxr Interaction repository, and I will in just a second get that running live on ngrok. So let me go ahead and boop, 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 close out of this, and I'm going to bring over my code to the Webxr Interaction. Okay. And let me close out the other one. 1 second. Too many windows running at once. Okay. So this right now, I'm going to run npm start, and then that's going to jump up my new server in a minute. That's going to pop up here. And
in case it's not obvious, Evan's running the terminal inside of Visual Studio Code. So
yeah. So that way I just don't have a separate terminal window. The terminal window runs down there. So that's just something, a convenience thing that I like to do to save myself having too many windows open. Right. Okay. So right now, if I looked at what I'm running right now, it's an empty scene. I deleted it's a skeleton. If you check out the code, you'll see the full example, but right now I have a skeleton, and we're just going to copy and paste blocks in. So like what I'm running right now is just empty. But one of the things that exist in here is there's some assets here. There's some 3D models. So I want to show you how you basically can import 3D assets in Babylon. Let's see. Oh, whoops, I have the wrong copy of the wrong one open. Hold on my other screen. I gotta grab it from the repo. 1 second. Okay, I got it. All right, so loading of assets in Babylon is asynchronous. And the reason for this is because you're not loading off of a local hard drive, you're loading off a server. And so because of that, it's going to make a request, but that request could take time to load. So you can't just like load a file and then just keep going. You have to do what's called creating a task. And you use this with what's called the assets manager. So here I'm actually in this example, I'm just going to get rid of Blair's default environment. Sorry, Blair, that all goes away. And then I'm going to create an asset manager. And that asset manager is going to use to control the loading and of assets. You do this first by creating a task for every asset you want to load. So for this one, I created an OBJ task for an OBJ file, which is located in assets. And it's actually a OBJ file. It's a free OBJ I found on clara.io. And then that won't do anything. That just creates a task, but it doesn't actually load it. What I have to do is then tell what happens when that task is completed. So this is creating on success. So when that gets done, it's going to actually load it. And then this is only one mesh. So it returns an array of meshes in case there's multiple meshes in your file. This one only has one. So I'm just going to name it a descriptive name, set some position, scaling, and rotation. So it's placed in my scene. And these are just values I figured out in beforehand. And then finally, that defines what's going to happen when the task is done. And then after I define all my tasks, I then do assets manager.load, and that actually does all the loading. So now if I load that up, it will, let me grab which browser window was it? There it is. Okay. So here's my browser window, and you can see the 3D model is loaded directly from that OBJ file. And you can see, see that there. There's one other asset I'm going to add at this point, and that is not in this window. How do these windows keep closing? This is unbelievable. All right, 1 second. Okay, I'm going to create a second task, and then this one is actually going to be really interesting. This is a GLB file, which is a GLTF file, and this is a file that actually contains an entire scene that was exported from Unity. And so I'll explain what I'm doing here in a moment, but let's load that up. This file, in the second session, we'll actually talk more about this because it's something that students wanted, so it's more relevant to teaching. But you can see this is an entire scene that was actually from a free Unity asset available on the Unity Asset Store. And I opened it in Unity, and then I'll explain that process later, but I was able to then export it into a GLTF, which is the basically 3D modeling for the web. And here I gave it the root, a descriptive name called node. It's called world, but if you look at this, the entire scene hierarchy from Unity was preserved. You can see there's props, there's a path. If I select any of these, let's see, in here you can see, oh, there's that one, there's all those buildings and things like that. So the entire scene hierarchy Unity was preserved here. I also put out on the console, I exported, so you can see all the, here in the developer console, you can actually see all the meshes that were loaded from that file. Okay, so that's it. So now we have a 3D world in here that is loaded. Now let's go ahead and copy and paste in the Webxr stuff, so then we can show we can show that off. So I'll copy and paste in the Webxr stuff right now. So this creates that default Webxr experience, and that's basically all I need. And I don't like the default teleportation with 3D meshes because then the intersection is an issue because this ground was not flat. So I just disabled. What I did there is I created the default Webxr experience helper, but then I disposed of the teleporter, and we're going to add our own custom locomotion in a second. But you can see now immersive mode appears. So if you have the Webxr emulator extension installed at this point, you go to that. If you click that ngrok io.link, you can load it. I have that ngrok link on my headset right now, so I'm actually going to go live on my headset with screencasting. And this is just the official Oculus screencasting. So if you just do this oculus.com.casting, and so now you're seeing a live screencast from my Oculus Quest, which is not hooked up to my computer. So it's a little bit of a delay because it's screencasting over the web. Okay, so this is what I'm seeing now. You can see what I have is this the Oculus browser. I have this phrase vrevan.ngrok.io bookmarked. So now if I refresh it, you will notice there's this immersive mode icon down here. If I click it, I am now fully in VR, and you can see I can wave my controllers around. You know, the quality is much better than what you see. It's obviously throttling the bitrate for the screencast. But you can see now that is a full 3D experience being loaded on the Quest as a standalone device. All right. So if you have a Quest handy, you can do that right now. You can enter that ngrok link into the Oculus browser. Just make sure it's HTTPS, not HTTP, because HTTPS is required for you doing Webxr. If you forget the HTTPS, then it will not work. Okay. Next thing on my list was the controller input. Now, for controller input, the way that I find this to be the most convenient is to create some member variables that I can assign controllers to, so I can create callbacks and things like that. So I actually add the XR camera and the left controller and right controller here. You'll notice this is Typescript, how they do definitions. Typescript has a really cool ability to have multiple typings for a variable. So you can see this is saying it's either a null or a Webxr camera or a Webxr input source. And it enforces these typings. And then I have to initialize them to null at the beginning. And then when we go in here, after we create this XR helper, what I'm going to do is basically then assign those to member variables. So you can see I just added this code here. I take the XR helper and the controllers. There's these events fire when a controller is automatically added. So then these get assigned to my left and right controller. So now when they connect, which happens when they click that immersive mode, all of these things get assigned, and then I can reference them later in my code. So let's go ahead and do that. The first thing I'm going to do is let's register a built-in pointer event. So I'm going to create a little event handler here called process pointer. I'm going to put this right here. And then this one has, you can see, basically just like it's an event. And what I'm going to do, I'm not going to walk you through this code right now, but basically what this is going to do is if you hit something with your controller, with your trigger button, it's going to enable and disable edge rendering as a highlight, and you'll see that. So you're basically going to be able to toggle on this on objects by clicking on them. And then all I have to do then to register that event handler is add a couple lines of code to register the event handler, which I will do right up here. After the controllers are assigned, I will register this. So on pointer observable, it just registers with basically this event handler with the scene. So that's all that needs to do. So now I save, it's going to compile and refresh automatically. I'll load it up on the browser right here. And the cool thing is that the way that this handles that kind of pointer event is that if you are not in immersive mode, it triggers it also with the mouse click. So if I click here, this is actually what happens with the mouse button. So I can actually click and highlight each of these objects just there. But if I go into immersive mode again, which gave me an error, maybe because I haven't tuned, oh, yep, I didn't have the window open. Okay, so that should work. Whoop. Do I have multiple windows open at the same time? Oh, I think it's my Quest. It's messing it up. That was interesting. Possibly the Quest is messing it up. Okay, well, we'll just do it live then. I'm gonna have to refresh that one.
It might be a code error because it shouldn't matter if multiple things are connected.
You would think. You would think. But I'm not sure. Of course, that's the thing I did with live coding, right? Is you know, okay.
The interesting thing is he could actually be clicking with his ray on the 2D window and it would be working just like with the mouse on the desktop.
You can see, yeah, so it was a problem with my, with something being connected at the same time. So you can see now, yep, I'm doing it live with my controllers in immersive mode and it works. So, okay. Okay, cool. All right, so I'm just gonna keep this on my head so the screencast doesn't go away, close automatically every single time I do that. All right, so I'm just gonna close that window since that was causing issues. So we did that. We did a simple controller move selection. One thing that exists in this code, and this is in that full version that you have here, is I've created a framework here that's basically for every single controller button, just basically logging out, has this component changed, and if so, is it pressed or not or released, and just log that out to the console window. We don't have these processed yet, so this is just an empty framework, but this is actually pretty easy to add. I'm just going to create copy and paste my little full thing here for all my event handlers, and this basically just is, don't worry too much about this, but this is basically saying getting the component for each one assigned with each button, and then basically then sending that to the appropriate event handler. And then all I have to do is then, this is the polling model. So I'm basically in my main update loop, which is called every frame. I'm basically just going to process this. So once per frame, it's going to basically say request and say, check all the controller buttons and then fire off each one of these event handlers. That framework, which is all in that code in that repo. So hopefully, if I load this now up on here, it will not give me that error again. I don't know why it's doing that. I'm going to do, oh, you know what? I'm going to be clever then. I'm going to do it on Edge. Switch browsers. You know what? I may have forgotten the HTTP. Oh, that's it. It's the
Oh, yeah, it's the.
It was the HP's TTS thing because I'm using Nginx. That's what it was, Blair. It was the HTTPS. That's why it was giving me that error. All right, let me. I'm so new to this entire ngrok thing. That is something Blair taught me. Okay, so now, mark my words. Okay, didn't work. Didn't work. I don't know what's going on with my configuration, but I'm pretty sure it's the ngrok thing. But if I was going to do that in the emulator, you would see essentially when I click each of these buttons, you would see them fire off. You'll just have to trust me on that and run it yourself because I don't know what's going on. That's never happened before, but I think it's most likely the ngrok thing interfering. So we'll try it one more time. You test everything in advance, and of course, it works then.
You're not secure there. I don't know if that matters.
It shouldn't matter because it's going through ngrok, right?
No, you still have to do the HTTPS on your side.
All right. Okay, well, let's just skip that anyway, because that's less interesting. That was just trying to show you. I won't do it in the emulator. I'll do it live. The last couple of things that I just want to really quickly do, and then we're going to close this out, is actually change one of these to do something real. So we don't need to look at these just like, oh, the button's pressed and released. We're going to change it. We're going to add, first, let's add some locomotion. So I'm going to go to the right thumbstick here, and I'm going to copy and paste this code that I have previously prepared. So right after this, so basically if there's a change in the axes, this does a snap turn by 45 degrees, either left or right, when it crosses a certain threshold. And then finally, this code here afterwards handles forward and backward locomotion. And you can go, I'm not going to go through that line by line, but you can go through it in that Webxr example if you want to dissect the code and see what's going on. All right, so I'm still running my screencast. So, and it's really nice. You see that once you have everything set up, all I had to do was hit the refresh button and then I'm here. So now I'm using my right controller. I'm using forward and backward locomotion. It's controlled by my head, so I can steer in any direction I want, and I can snap turn by 45 degrees. And again, this is live on ngrok now if you want to try it out. Okay, so we did locomotion. I'm going to add one more quick bit of interaction code, and then we'll call it a day on that. And that's going to be for grabbing objects. We have a question in the Discord. The question was, what is all captured in the GLTF file of the Unity scene graph and models, or animations too? I have not messed with animations to my knowledge, or at least the only thing I have tried is scene graph and 3D meshes. Babylon does support animations, but I don't know how to do that from Unity. I have not attempted it, so I can't make any comments about whether that is possible or not possible.
Yeah, and the Unity scene exporter it's on the, is it a Chronos thing, like, or is it just on GitHub? We have the link in the next section, but
yeah, I'll cover it in the next session. We'll get into that, but yeah, it's a Chronos group exporter. So okay, so in order to do this, I'm just going to toss in a couple more member variables up here to control the current. I'm only going to do this on the right hand. I'm right-handed. Sorry for the left-handed people. You can add the left-handed code if you want. I'm going to create something to store what's currently held by the right hand, and I'm going to create an array of grabbable objects that's going to store references to anything that can be grabbed. I'm going to initialize those, empty array, and null object at the very beginning. And then what I'm going to do here is is look down here, and I'm going to add everything that I want to be grabbable in the scene to the list of grabbables. So if I look back here at the actual contents of the scene, we remember here's the world that we loaded, and there's all these props. So anything that's a child of this props thing in the scene graph is something I might want to pick up and grab. And I can do this really easily if I know kind of the layout of the scene graph that I exported from Unity by simply searching through I'm going to do this actually in the very end. So this, after the assets are done loading, I can add another event handler. And this basically event handler gets fired off when every asset in that assets manager is loaded. So both these tasks are all completed. Finally, then this will get loaded. What it does is it takes the adds to the grabbable objects array. It pushes the object file, so that little Pokemon 3D model. And then for this one, it searches through the world that I see task that's seen from Unity, and then says if it finds a mesh where its parent is props, then add it to a grabbable. And then I deparent it so that we can essentially, by deparenting it from the object, then it becomes free floating, and I don't have to worry about parenting relationships if I grab something, messing something up. So that makes them all grabbable. Now all I need to do is add something to my controller button to do the grabbing, which I will go down here to right squeeze. There it is. They called it, I like to call it rip button. Webxr for some reason called it squeeze button, but whatever. I'll just use their convention. When the button is pressed, what I'm going to essentially do is basically look for the grabbable objects and make sure we haven't currently grabbed an object. And if our grip intersects one of the grabbable objects, we basically parent it to the controller. That's all that does. Again, not going to do it line by line. And then finally, when it's released, I simply say if there is a currently grabbed object, set the parent to null, and then basically make sure that reference is null to so it's no longer grabbing an object. The set parent function preserves the exact position in the environment, so it does not change the location. There's another way you can set a parent function and actually have it change the location based on the scene graph, but set parent keeps it exactly where it is. And that's all we need to do to make us be able to grab an object. Okay, so let me go back to the screencaster, demonstrate it, and I just have to refresh. Moment of truth. You can see, yep, I've got my object, and then that was the one I added. Let's see, these are props, so they should be also grabbable. Whoops, that's my monitor I just banged into. You can see, yep, I can move those around. I can grab, this is a prop 2, can grab that, move it around in the scene. And there are more complex examples in my courses page, which we'll cover soon, which has all the open source assignments where we actually went beyond this and added physics and things like that as well, because there's physics engines in Babylon. Kyle Johnson said in the Discord that the performance isn't the best in the Quest 2, or you're going to cover performance optimization. No, we're not going to do that explicitly, but basically the performance, the problem is that that was just the scene, right? You know, so it's not anything related to Babylon. That Unity scene had too much in it, and frankly, I had too much to do getting ready for this tutorial to go through and optimize it. So I'm sorry if the frame rate is a little poor. That is just because, just like with Unity, I just picked a scene that was too big and didn't bother doing the optimization just due to time constraints.
I mean, there is a larger meta question, which we haven't really directly said, which is Unity, the downside of the web versus Unity and Unreal and so on is that you're not going to get the same performance because they're running natively, which the web is actually is pretty good, but you know, JavaScript is single threaded, so there's a bunch of things that you can't get there. And Unity and Unreal are highly optimized. So the performance isn't necessarily going to be as good, but for all of the stuff we do in our classes and research, it's fine. And then there will be features that Unity and Unreal have that Babylon and others don't have as well. So it's not like a throw at Unity, throw at Unreal thing. It's a different set of advantages.
Yeah. Okay. Just a couple things we wanted to also point out, and this is not stuff that we'll cover because I don't think either of us have extensively looked at this. I haven't really messed with this at all, but also Babylon has an online node material editor that is just, it's interesting if you're into that type of stuff. You know, more tools at your disposal. And then as well, this is actually somewhat new. So I actually don't have anything prepared on it other than to note that this exists. One of the most common things I heard from students was that they wanted a WYSIWYG style scene editor like Unity. And yes, you can export Unity scenes, but they wanted it native in Babylon. At the time I taught the class last semester, this was kind of more in like a beta stage. Now they have like a real release of this Babylon editor, which you can get at editor.babylonjs.com, which is open source. And I messed around with it very briefly this week when I realized that they had updated it substantially. And it's pretty full featured. This is getting more and more towards like actually having a Unity style development environment for Babylon. But like I said, this was not available really when I taught the class last semester. So I don't have any, I haven't had yet enough time to really explore it and learn it yet. But it's a pretty interesting thing to see how well it's been developed over the past 6 months. With that, I believe we can answer some questions and then we'll move on to the part that's more focused on teaching. I'll get that queued up while we are waiting. Okay. So the slides are for tutorial 2, or session 2, which I think we're just going to run right into now, just due to time constraints, are now also posted. They're a separate slide deck in both Discord and in chat, and we'll have hopefully some time for questions after that. We're not going to be doing any more live coding now. This is more going to be focusing on the use of WebVR in the classroom and our experiences doing that, and kind of lessons learned and tools that you can use to, so resources and things that will hopefully be useful for everyone. How is exporting items from Blender into Babylon? Same process as Unity. Actually, Unity, I had to install this sort of Kronos group extension that does it quite well. Blender has a native exporter to GLB, or GLTF. So Blender UCAS, you can just export it right out of there into that format. Or again, OBJ files as well can be loaded. So you can also, anything that you can use to convert to an OBJ file, you can load.
But the Blender into Babylon is like the standard workflow. Like Blender to GLTF is what most of the GLTF working group uses. And so GLTF supports a ton of stuff, and the Blender exporter is really good. And a lot of GLTF is now like the standard for web-based 3D. So all of the graphics, all of the game engines and stuff on the web have really, really good GLTF support.
Yep. All right. So our agenda for this part now is starting first with why use this for teaching. We're going to go over sort of our experiences using this in the classroom, both Blair and myself. I'll talk more about how that Unity editor stuff works. And then finally, we'll talk about some tools and some active learning things that we did. Go ahead, Blair.
Okay, so I think we've covered some of this at some level, but we wanted to be really explicit on it. So the advantage of using web-based stuff in the class in some ways comes down to logistics, but also pedagogy. So for example, Georgia Tech requires all students to have a computer, and in computing, we require all students to have a laptop, with the idea being that they can bring them to class for active learning in class. The problem is many of our students are not rich, and they're not upgrading to the latest gaming laptop every year. So their laptops aren't awesome for running 3D. And also we don't mandate OS, right? So web has the advantage that you can as long as you have a text editor and so on, you can basically use it. Even face-to-face, a lot of these old computers don't run Unity that great, and it's low-res laptops tend to be not great with Unity's UI. And there's other things you can do. So like the stuff Evan showed, and we've been showing with ngrok, I use that in class and have the students run it locally. We also do things like here's a bit of code in GitHub, go download it, and you can hack on it. And the turnaround works really well. There's also other things. So Microsoft has this live share thing for Visual Studio, and VS Code supports it. So students in class, if we're hacking, I can sync with them and display and chat about their experiences. So so there's a lot of sort of useful things that have to do with that, and it's just useful for students to learn web-based tech stuff.
Yeah, and I would add, we don't have that policy for laptops at the University of Minnesota, and many of our students, we're a public university, some of our students, the best they have is like a Chromebook, right? So they can just remote into like our computer labs or something like that, or some of the students are completely dependent on computer labs. So I had students, when I taught the class in Unity like a year ago, who just, they would bring it to my my office and want to like show me what they did, but it took 5 to 10 minutes to make a change and build to the Quest, because that's how slow their laptops were. And that was just, I felt so bad for them because it seemed so painful.
Yeah, we had in my classes, I had a lot of students that were kind of grumpy about not using Unity because they wanted the latest greatest, and a bunch of them knew it. And when we got to the individual projects, some of them stuck with Unity, switched to Unity, but a bunch of them switched back for that very reason. They're like, oh my God, the build times to a mobile device are just completely insane, when I can just change and refresh. So for teaching, it ends up being pretty nice. Someone asked about AR. Yeah, Babylon supports AR on the Webxr devices that support it. So Chrome really. Apple hasn't released a Webxr for iOS yet. When I was at Mozilla, I developed this Webxr viewer for iOS, but it hasn't been updated since Mozilla shut down the research group last summer. They also support, which is super cool, stuff on Chrome on HoloLens 2. So you can do AR on HoloLens 2 as well. And Babylon Native actually has a bunch of weird non-standard extensions that expose a bunch of HoloLens 2 stuff into Babylon. So that's actually also kind of cool. Okay.
Okay, moving
on. Yeah, and so I think we said most of this. The compile loop stuff is important. The text editor command line and Git tooling it just makes it easier on the students in terms of what they have to install and how powerful the machine is. Supports Linux, supports. I've even had people do web dev on Chromebooks. The big thing for me actually is looking inside the editor. I sort of showed that a bit in the code, or looking inside the engine, being able to like dig in and flip through it. And I've had students go in in assignments in the past, I can't remember if I did it this, take one of the things like the teleporter and fix it or change it in a certain way, or do that, which is just super nice to be able to go in and change the engines. To develop programs for research. I don't know what you're asking, Antonella. Do you mean in terms of what kind of output? You mean to what kind of devices? Babylon Native supports phones, tablets, desktops, standalone VR devices, desktop VR, and yeah.
Anyway, I'll address some of that research question on one of the later slides as well. Great, move on, Blair.
Yeah, although I'll answer this other question. To reduce student anxiety, we did a bunch of small startup assignments so that they could get comfortable with all the tooling, with TypeScript, and provide external help. But basically what I tell the students and what I believe is that every language you learn, every framework you learn makes it easier to learn the next one. And in general, the students, I had a student come up to me at the end of the class and she was bouncing with excitement. And she's like, this was the best class I ever took because I've always wanted to learn like how to do proper web development. And this is the first class that taught this. This is my graphics class, right? She wasn't excited that she learned graphics. She was excited that she learned TypeScript and web dev. So it's a new thing, but I just gave him help and had ramp up assignments at the beginning that weren't diving right into 3D.
I think also the fact that you can kind of show them how TypeScript works first, right? And kind of normalize it and show them, hey, look, TypeScript, if you've done Java or C# or C++, TypeScript will look very, very familiar for you. When I'm programming in TypeScript, I really don't feel like I am programming in like a JavaScript. I feel like I'm programming in a real typed language.
Yeah. And that's sort of what the reason I migrated to Babylon versus the other ones, even though I had reasons to use Babylon in the class I taught, but safety and TypeScript, students, you want them to spend like 3 hours an assignment, and if they mistype a component name and it's just crashing and they're wasting tons of time in development, that's like a lot of time not being spent on the actual material. So lots of dumb errors get caught in the editor. I like Babylon for teaching because of its more opinionated level, right? It just gives you a lot more out of the box than something like 3, even though it gives you maybe less flexibility and bigger results. And it's very, and for me, for 3D and for a 3D UI class, being able to have a very elaborate UI system was a huge win as well. Okay. Okay, so briefly at Georgia Tech, we put a bunch of links here just so you could go and check it out. I actually started teaching with Web and Webgl when I taught graphics in 2015. I went on a very long leave, and then I taught graphics again. And so the most recent class is up there in GitHub. As I said, most students really love the fact that they were learning these new things, or at least didn't hate it. Some hated it. But the ability to be able to use the web and so on made things pretty good. So flip to the next slide. Figure we're making up time at this point. Yeah, so this is the kind of sample that this is the last assignment I had in my graphics class, which was make a web-based 3D interactive Christmas card. And so every character they typed in the window, it was dropping these things in. They could hit delete to delete a character, or hit some key to just blow everything away. And then they could go in and have a fixed message and mail it to somebody, and so on. So this is the kind of stuff you can do in a class with these tools, which is not, this is just running in a web browser. One of my students, Jim Nguyen, shared this with me to show. Okay. So similarly, but this last year I taught this, and this is where Evan and I started sharing stuff. So last spring I taught this 3D UI class, and then I taught it again in the fall. The big thing for me is that I didn't want to teach a VR class while I had to use a lab. I'd been there, done that. I taught game development with a lab of Xboxes. It's awful. The students don't want to be there. Students put off working on things as long as they can. It's unnecessary stress and annoyance, as opposed to everybody has their own self-contained thing they can work when and where they want to. So the Quest finally enabled that pre-Oculus TSO change in the fall. And so I bought a bunch of Quests, gave every student one. The first time I taught the class, I followed one basic model. I switched it around a bit the second time. And then I had added some Windows mixed reality stuff in because I only had 30 Quests. Microsoft loaned them to me, which I was very grateful to. It actually ended up working great for remote, right? Because everybody had their own device. Everybody was at home. I had to mail some to Colorado and Boston and so on, and made the students outside the country buy their own because I didn't think I could mail them. But everybody having their own, and then using the web stuff and using things like live share. I was hanging out with students late at night, looking at their code with them on live share, and they were at home and I was at home. It was great. Okay. So the thing I think that makes the class I taught and the class Evan taught slightly different is I really focused on 3D UI and not, and actually I won't put words in your mouth, but that from a lot of the VR classes that I've taught in the past or other people have taught is that I wasn't particularly focused on VR AR project design. We have a AR project experience design class that I also teach sometimes. I really wanted to do kind of a 3D version of a UI toolkit class that we teach, where students really learn how to build these things efficiently, how the engines work, how interaction techniques work, not like application-oriented stuff. So I ended up following the 3D UI book pretty closely in terms of ordering and content. I added a bunch of 2D content that I took from this 2D UI class that I'd done because 2D UIs are more elaborate, more standardized, and because 3Ds aren't, starting with 2D UI, how event-based systems work, how repair damage works, and then talking about how the analogs in 3D work and how they're different and so on worked, I think, pretty well. And my slides are all up if you want to poke at them. We did a bunch of assignments that built on each other or explored different things, and then had the grad students do an independent project. So I think it worked pretty well in that way. The interesting part, again, and we'll touch on this again at the end, because we were remote the last semester, I had, actually, I did this both semesters because we were remote by the end of the spring as well. We use Mozilla Hubs. I had each student project group create a Hubs room as their project presentation, and then we went in and had the students present in VR. In the spring, it worked fine because we had a small class and Hubs supported 20 people pretty easily. Because I had so many more people in the fall, we had the student groups present to the TAs and I, as opposed to presenting to the whole class. They presented a video to the class and then did the longer presentation to us in Hubs, which worked well and was pretty interesting.
Okay. Yeah, my class has some commonalities with Blair's, but also some differences. There's a big focus on 3D user interfaces. I also do follow the 3D UI textbook in its conceptual topics. However, what I also really had, I think, a pretty hands-on programming development focus as well, kind of alternating between each week. There was usually some sort of lecture on 3D UI stuff, and then also like a hands-on live coding lecture, then with programming assignments that are paired up with different interaction techniques using the Oculus Quest. There were three possible, for in terms of like their final project. This is another difference, I think, from Blair's, is that there were three possible project focus areas. Students could choose to work on something involving some sort of technical novelty, like adding toolkit capability, novel 3D interaction techniques, or some sort of novel application, but all required some degree of novelty, and they had to propose some and justify it and write a paper on it and all that. This was taught remotely. I taught with this model in Unity the previous year, but for given remote challenges, this is when I made the transition to Babylon in fall 2020. We had 60 students. All of the students received an Oculus Quest headset. Similarly, most could pick up locally. A bunch of them did need to be shipped and we were able to ship it. I actually stupidly did try to ship to several students in like 2 students in China and 1 student in Taiwan. We had export control restrictions that blocked us from doing that. And so what happened was my department basically just had them buy it locally, and then we reimbursed their student accounts for it and called it a COVID expense. So my department just ate the cost. All the course materials for this, including my lecture videos and assignments and everything that I did, is all available open source. You can find it on Canvas, and also all the assignment code and things like that is all available on GitHub as well. But all of that can be linked through that Canvas, found through that Canvas. A few different things that that came out of that class. These are all ones that students consented to show publicly and uploaded YouTube videos for. This was one final project, which was working with our Medical Devices Center on campus. This is actual brain data. They had some problems processing the data in the 3D mesh to decimate it, which is why it's kind of messy. But this was actual MRI and CT scan reconstructions. And so this is a tool for allowing someone to plan an invasive therapy procedure, basically deep brain stimulation. So a probe has to penetrate, and you want to avoid, you want to get to a stimulation site that's highlighted, but you want to avoid damage to the brain structure or brain tissue. This is actually a entry this year at the IEEE VR 3D UI contest. Next one. All right. This one was a toolkit-based project, more of a technical project. They actually implemented several inverse kinematics solvers that were fairly advanced solvers in Babylon. So this is a CCD-based solver. You can see, so this is basically based on just the controllers and the headset doing at least an upper body avatar model that and they and like I said, they implemented multiple different types of IK based solvers in order to compare their results. And then this one was another technical based project, so it's not as flashy, but it's super interesting and cool that they were able to do this. These two students, Angel and Allison, were able to actually use something called matrix.org, which is a decentralized way of synchronizing information built for chat and other types of things like that, and through JavaScript, basically to do multi-user experiences. So these are two, they're loading the same environment through the same URL on two different quests, and you can see what happened here is that one person on her headset grabbed the object, moved it, and then it's synchronized on the other person's, and they can see each other's avatar representations. So kind of they did the groundwork to lay the beginnings of a true shared multi-user environment just loaded through the web browser, which was quite an impressive feat, I think, that they were able to tackle and actually make that work. All right. Okay. So my experiences with this was actually my student evaluations for this class in the fall running remotely were actually higher than in person in Unity. They were really strong evaluations, and I think students really appreciated the fact that that I was really explicit about the reason we're doing this is so that we can have greater accessibility to VR and Webxr. Otherwise, the students would have been disadvantaged with laptops or Chromebooks or things that just can't run Unity because they don't have access to labs during the pandemic. The number one thing that students who said they absolutely loved, I received so many positive feedback about the fact that they could just code, hit refresh, and then immediately see the result, and just do things like that with such a fast dev testing loop. That was really popular. And then the fact that we were able to do these live coding lectures and really speak, and because everyone could kind of like follow along with the code, and it was very lightweight, and they could check it out through GitHub and stuff like that, it was really became much more active and fun to do that live. Whereas Unity, it's a lot harder to do that with an entire Unity project, where here you can just grab the code, copy and paste this in, and it's lightweight enough that 60 students can actually do this along with you. So this got a lot of points for being really fun and engaging. By far, the most frequent negative comment I received was the fact that some students wanted a WYSIWYG interface because they just wanted to do everything in a GUI and not actually program. So that's why I introduced that pipeline for at least importing static Unity scenes into Babylon. But my response to that criticism often was, this is a 5,000 level, computer science class, upper level undergrad, or graduate level class, right? Like, if you're wanting to just use a GUI to get through that class and not program, then you're kind of missing the point. So some students appreciate that. Some students still just complained about the fact that they just wanted to do everything in Unity, but you know, what can you do? So that brings me to Unity. I will quickly bring up my Unity scene exporter. So this is, as I mentioned before, this is a Kronos Group Unity GLTF plugin, which the link, which is currently blocked by my Unity loading screen, is here in this right there. You can just Google it and find it on GitHub. If you are on Windows, you do need to compile it because there is a binary component, but it didn't take me that long to figure out how to do that. And whoops, and did Unity actually load here? There it is. Okay, so here's that scene that I showed you that I before that I exported from Unity, and the Unity GLTF I installed once I compiled it in my assets folder, and then it just creates this little GLTF thing right here. So all I needed to do at that point to export that was basically just to select not the lights, but all the assets in the scene, go to GLTF and do export as a GLB. And then just, it's literally just selecting the folder and then it exports the GLB file. And then it, like I said, preserves the scene hierarchy and everything. So it's was a really good thing. And I think a lot of students took advantage of that because not just for building scenes, but now you have opened up the entire Unity asset store, right? So students could just search for Unity assets, import them, export them as GLB in like a very easy way without having to mess up with like lots of online model conversions and things like that. They just export directly from Unity and GLB. The one caveat for here is sometimes crazy material shaders are a problem. It supports the standard shaders, diffuse shaders and things like that. But if assets use like custom shaders and things like that, obviously those aren't going to be supported because the GLTF exporter does not know how to handle weird custom shaders. If you want extra detailed instructions and a walkthrough about how to actually do the whole Unity GLTF workflow, I would refer you to the following video. So all of my GitHub lectures have a link to the video where I actually show you and I walk them through students live through how to do it, the entire workflow. There was a question in Discord, one about research and then one in general, and then another one which was, is Babylon.js a useful tool for building cognitive experiments? Is it possible to create a data file like a CSV or XLAX file, on which to save metric distance and centimeters, reaction times, things like that? The answer is no. You can't create a local file on like that on a user's computer because of browser security restrictions. And so how we would do this for research is a question that we had to confront in my lab. So this is what we did, and I think I've scared my sound, so I'll just let my student explain it. This is an IEEE VR 2021 poster, so it's shameless plug, it's a 30-second video.
The RED Toolkit is a novel system designed to effectively handle the collection of real-time data for remote user studies. This toolkit consists of a REST server implemented using the Flash framework and a client API for transparent integration with multiple game engines. The toolkit supports administration of remote experiments and collection of data from remote or standalone VR devices. We have built a Unity, Python, and JavaScript client, which we are currently implementing into Unity and Babylon.js experiments.
Right. So basic bottom line there is that this is a server that you can deploy on any. This is something that we have deployed on a server here at our university. You can deploy it, and then we have clients for both Unity and for Babylon.js that are working, and you can use this to record experiment data, and just by setting up your environment with an experiment key that logs the participant information. You can do it for like larger trials, or metrics, or actually it supports per frame logging. So if you want to export like tracking data and things like that. To answer that question directly, you can't easily create an Excel file or CSV file, but this is a toolkit we open source and hope that it will be useful for the community for running remote user studies in both Unity and Babylon.
The RED Toolkit is
shameless plug over.
Yeah, oh, and there's, as is common with the web, there's lots of ways you could approach this depending on your infrastructure, right? If you have servers, if you already have like experience with Firebase or SQL or whatever, or web-based server stuff, you can do it yourself. But having something pre-built like that prevents you from, or helps you avoid having to learn all that stuff. But there's a lot of different ways you could integrate this stuff in.
Okay, I think Blair, this is your part.
Okay, I will switch back over. Over in the chat, Bruno, I think they're recording it. They said they were going to record it on Twitch. I hope. So hopefully it'll be available for replay. Yu Yang, I'm not exactly sure I understand the question. Webxr just runs inside a browser. There are limitations, right? So someone needs to implement whatever it is. So you could, things like hubs, for example, hubs.mozilla.com is a shared virtual world that runs using Webxr and runs inside the browser. But as of right now, it doesn't support the same number of people as Verbella does. So I think eventually web-based stuff will fill some of these holes and not require installing of apps. But right now, for more use cases, but it'll take a while. Someone has to build it, right? Okay, so both Evan and I, one of the big other things that I wanted to solve and with teaching using, sorry, let me share my screen. Oh, you need to stop sharing yours, Evan. Oh, I can just continue and force you out. Where is my projector? Okay, so one of the other problems that I think a lot of us have with doing programming things is how you distribute and submit classes. This isn't particular to the web, but because web-based programming is particularly amenable to setting up an entire package and complete self-contained thing on GitHub, GitHub Classroom turns out to be a really, really good solution. So if you go to classroom.github.com, which I will paste here in the chat, you'll see something like I see here, which has a little bit of overview of what GitHub Classroom is. The basic idea of it is you create a GitHub org for your class. And once you have the GitHub org, it's available to be set up as a GitHub Classroom system. So I'm going to sign in. You sign in with your GitHub account. It should just let me sign in there. So when you're signed in and you go to that website, you see all your classes. So I've used it for I used it for graphics last fall or fall 2019, and I used it for my 2 3D UI classes. I also created a simple one for this class. I'm going to show you kind of what it looks like inside here. So I set it up and gave it some basic things. It's actually set up on the org we created for the tutorial. So it's on that same web-based VR tutorial org. And I created an assignment. So you can go here and say new assignment. And you give a title, deadline, you say whether it's individual or group. You can control the repository visibility of the student repositories. So in some cases, let's say it's an after-school program or something where you're not worried about FERPA students not being able to share code, you might make them public. Generally, you make them private. And what happens then is when a student accepts the assignment, they get a copy of the assignment. The repo is private, so only they and the instructors and TAs who've been added to this, they will automatically get rights to it as well. And I'll show you this again. So I'm going to cancel this. So I created a sample assignment. And so if you want to see what this looks like from the student side, if you haven't used GitHub Classroom, you can go here and pretend you're a student and accept the assignment. The assignment code is that basic, that first repo, first demo. So what you'll get inside of, so let me flip over to here and go here. So here's our repo, and you'll start seeing, since I'm an admin and Evan's an admin, we see all the private ones. So two of you have accepted the assignment. You can see that they're private repos. It gets a little unwieldy with large classes. So with in graphics this fall, I'll have 120 students and maybe 5 or 6 assignments. So I'll have almost 1,000 repos by the end of the semester. But so the idea, so now each of these repos is essentially a clone of the Webxr template, the one that we taught, okay? But it's only visible to the students and Evan and I, since we're the instructors. And GitHub Classroom takes care of doing the initial commit from the template. And now the students can work on it as they would. When students go and submit an assignment, so actually let me see if there are, so now there's 2 students here, right? And I can go to their repo. There's GitHub has a Classroom Assistant app. You can go to it, pick it, and it'll download all of the submissions as one blob, extract them into a directory, and so on. And then I had a student, my TAs wrote a little script that would go through, CD into each directory, and run npm install and npm build, so that we could go through and grade them. The nice thing is the submission at the time that you set as the deadline is wherever the state of the repository is at that moment. Oh, did my camera die? Yes, it did. That's unfortunate. Yeah, I'll fix that in a sec. And so the sorry, I got distracted by my lack of camera. And so the yeah, so the students commit as they want, and then at the deadline, GitHub Classroom marks a tag at that point, and you can get the state of the repository at the time of submission. But I found this be super useful for talking with students about their code, right? Instead of the student coming into your office hours and saying, here's my code, show it to you, say in Unity or something. I told them, it's like, commit your code and we'll look at it. And they would send a question, and I could, when I had time, go look at their code and make comments there or to them and send it back, and they could work that way. So it made it easier for me to have asynchronous chats with students about problems they're having. The other thing that's also nice is it forces students into a mode of work that has them committing their code onto repositories. I'm sure anyone who's taught a class has had issues where someone's laptop is stolen, laptop crashes, hard drive dies, and student work is gone. If they get into the habit and are essentially, this is like the path of least resistance is now to occasionally commit your work. So I found that to be super useful. So anyway, I found it worked really well. I used GitHub, my TAs used the Classroom Assistant to download all the assignments, and I would too, because that way, if there's problems in each of them, it's easy to check right there. Evan actually had them submit a different way. And I think is that on another slide, Evan?
Yep,
is there any questions about GitHub Classroom while I'm here? Yeah, as Kyle says, it's nice for group projects. If you set up a group project, the students can either self-assemble or you can assign them into groups, and they automatically get added as collaborators on the same project. It's super nice. And essentially, I would put all of my assignment info in the README for the assignment. So if you go to either of my classes, you'll see the entire assignment description in the README, including the how it's going to be graded, the rubric, and all that. And then in Canvas, which we also use, I would just put a link to GitHub for the assignment. And we would use Canvas for sending comments back or doing final grading and comments. So I would just use Canvas as the place to put grades. Anything you want to add about GitHub Classroom, Evan?
No, I think you covered it all. I also used it upon your recommendation, and I found it to be super, super valuable and just streamlined a whole bunch of the process.
Okay, and unshare if you want to. I gotta figure out how to my camera.
Okay, I've got it back. All right. So in addition, though, I did do, as Blair mentioned, one other thing, which really, I think, further streamlined the way we did our grading. And that when they commit their code to for any programming assignment or project, they have to submit a filled in README file. And part of that template, the things that they have to fill in was they have to document all their third-party assets, but they have to submit a build URL. So they actually have to build their dist folder, and then they have to upload it to a directory in their university-controlled web space. We actually had ways to streamline this with what's an rsync script. So actually students could do this kind of in a more automated way, or they can just FTP in or like SSH in to their home directory and edit. What this meant was every time the TAs went to grade something, all they had to do was like look in the repo in GitHub, click on the build URL, which is only visible to the TAs and myself, and then grade and then the binary version basically they just can copy and paste that into their Oculus Quest and then grade it right there without having to check it out and compile each and every one. Now, obviously, there are edge cases here for students that there are errors and things like that where you do have to check it out and look at it more closely. But for grading the final product, this made it easier. So yeah, there's in the Discord, Kyle and Blair are discussing the fact that why not use GitHub Pages, and it's because GitHub Pages are public, whereas the university controlled web spaces, you can actually password protect them if you want. And but yeah, anyway.
Yeah, the password protect is a good idea. I might
Really was a nice
experiment
way
with
to streamline grading.
Yeah.
Next topic that we have is the incorporating active learning. And so this isn't necessarily, in many cases, unique to Babylon, but it's some of this is, and then some of it may also just be other things that are valuable potential things that we wanted to share that is useful in a remote teaching context. Blair, you want to cover the first part?
Sure. So, I mean, we've touched on this a few times, and we're not going to give specific examples here. But of the in-class exercises, you know, my classes, it was kind of a mess the last two semesters with the pandemic. So things were not exactly working out the way that I hoped in every case. But I did it in graphics before, which is I would have a little gist or a GitHub repo, and the students could download and do work in class on an exercise. And the flow was really good, and the fast turnaround was really good. And so the fact that everybody could work on their laptops, the fact they could see the results, that they could download things rapidly, just made it a relatively low friction experience. Now, you know, you could send out a Unity package if everybody was on a Unity or a Unity project. I mean, if everybody was running Unity, but that goes back to the issues of not having, not everybody not being able to run Unity on their own machines necessarily. So if your students all have laptops and can bring them, then you have this opportunity for doing stuff in a pretty streamlined way. The things Evan and I wanted to point out are actually different kinds of active learning that we did. So we'll talk about them in turn. The first one is sort of using VR and social systems like GatherTown as part of the class. And then Evan is going to talk about one of the exercises he did that he really liked, and he also used GatherTown for. So if you want to switch slides. So I put a clip of on my website for the most recent 3DUI class. The schedule is there, and so I put a clip here because one of the questions I had even when I was teaching face-to-face was where to put all of the background material that's in the early chapters of 3DUI, right? The history, the technology overviews, the human factors stuff, human perception stuff. Because I knew I was going to have a good amount of time before the students all had displays set up and could do VR, what I did was I put the stuff up front and then took advantage of the fact that we were remote and that I wanted them to get experience with both desktop 3D UIs, using them before they start building them, and immersive 3D UIs to use Hubs. So Mozilla Hubs, if you haven't used it, it's at hubs.mozilla.com. It's a web-based social VR platform. We used it in VR last year. I set up my own instance of it, Hubs Cloud, that was private to my class, so I didn't have to worry about FERPA issues like privacy issues and so on. For non-Americans, FERPA is a government law that has to do with demanding that we don't expose student information, even if they're in a class. And so I basically did a two-step thing where we talked about the history of VR. I had a few lectures on it. And then I told the students, pick any topic from the history of VR and AR and VR 3D and 3D technology. Go research it a little bit more and make a poster. And you're not going to be graded harshly on the content of the poster. It's more that I want you to have something to talk about. And then we set up a Hubs room, 3 Hubs rooms actually, because I had 30 some odd students. So I divided into groups of 3. Within those rooms, there was 10 or 11 students in each room. We divided those into groups of 3. Then we used a class period to have a third of the time group A was presenting, a third of the time group B was presenting, a third of the time group C was presenting, and the other 2 groups were visiting and talking to them, just so they could experience like navigating with keyboard and mouse in the desktop case, seeing what it's like to experience spatialized audio, see what it's like to sort of have to move around and position content from you're using it for something viewpoint. And then after that, by that point, they all had their VR displays or got them shortly after. And so for the perception and cognition and human factors part, I had them do the same thing again, pick any topic in that space, make a poster, create a second set of rooms. And now everybody had to attend in VR and go through the same exercise. And the students really liked it. And they liked it for 2 reasons, right? So in the remote context, it's a pandemic, they just liked talking to people and not being in video. But also the fact that you could break up into groups. Like one of the things that's exciting about using VR for in-space chat is the ability to break off into small groups and talk without having to go off into separate Teams rooms or go to a different group of video. So that worked out really well. And the students also, I think, really benefited from having to use 3D UIs actively before going on. The other thing I will say is it also exposed that of my 30 some odd students, about 10% of them couldn't do VR for more than 5 or 10 minutes without having simulator sickness. And you know, these are self-selected students who are interested in it. And so I think that is also something that's interesting, is we still aren't at the point where we can assume that the advances in technology really will fix some of those old problems for everybody. Okay. So that's an image of what it looked like. You know, you can see in the lower picture, I grayed out the names, that students were broken off into different groups talking about different posters, and I'd adjusted the audio settings to based on how far apart I had the posters, so that you would primarily hear the people near you, but you'd hear sort of a rumble from the rest of the space, which was nice. There.
Okay. Now I want to talk about the one that I did. And so this one was framed around a speculative ethics exercise. I've, over the past few years been working ethics more into each of the classes that I teach. And so this one was inspired by Casey Fischler, who's a professor in, I think, University of Colorado Boulder, I think where she is now.
Yeah.
She introduced this one to me, and she has a Medium article that you can Google on here that documents it. But basically the idea here is to basically do a speculative ethics exercise that's framed around the TV show Black Mirror. It's basically framed around the following question, basically asking them to think about future possibilities for immersive technologies, including VR and AR, and then ask the following questions. What are potential social implications, ethical issues, regulatory challenges? And then beyond that, think about a cautionary tale that might illustrate some of these challenges. Basically ask them to come up with a story about a fictional person in the future that could illustrate this caution. It kind of makes this sort of like a more concrete thing that's like, a little more creativity. And I mentioned I'll get into the Black Mirror tie-in in a minute. The way that we did this is using GatherTown, which many of you may be familiar with. For those of you who aren't, it's basically a video conferencing platform, but there's a 2D spatial component using basically like retro style 2D game characters. And you can move through the environment. And basically when you move close to someone into dedicated zones that are for small group interactions, you open up kind of pairwise connections in small groups. So basically, it allows for a self-organization of small group interactions instead, as opposed to doing something like Zoom, where breakout rooms really come from the top down. If I'm in another meeting where like I'm in a huge group and someone just says, "Oh, we're in breakout rooms," and you're instantly teleported in there, and then you have this amount of time, and then like it cuts you off mid-sentence and teleports you back, I'm gonna literally pull the rest of my hair out. There's just not much left anymore. But I like the organic nature of GatherTown. Joachim says GatherTown is not my cup of tea, and that's fine. GatherTown isn't perfect, but there's a reason why I used it in the context of this class. And you might ask, why not use Mozilla Hubs? I do have a self-hosted Mozilla Hubs at the university, but the issue is scalability. My class is double the size of Blair's, and I only have one TA. I think, Blair, you have more than one TA for 30 students, right? Yeah, so it's just me and one TA for 60 students. Yeah. Yes, Joachim says nothing personal. I didn't take it personally. I don't have stock in GatherTown, so I just thought for this particular exercise, I liked it because I could allow students to kind of more organically self-organize in a one platform where I didn't have to jump around like 10 different rooms to monitor who's doing what. And then everyone's able to report out afterwards. The framing of this Black Mirror is, for those of you who are unaware, Black Mirror is sort of like a science fiction show that on Netflix that explores the future, like kind of dystopian, but like future negative impacts of technologies, but does it in a very plausible way. And so the way they report it out is basically by giving them this blank slide, which is basically framed as a Netflix episode synopsis, and then they had to complete it. And so this was another reason we didn't do this in VR is because this lasted like an hour and 15 minutes. So I didn't want them in VR for an hour. And these are just a few examples of what students came up with. Some of them a lot of the students, some of them were more tangible, and then some of them went really like full off, like Matrix style. So like a little bit missing the point in that next time I do this, I have to make there so that they're like thinking more concretely about like something a little bit more grounded in reality. But there were some interesting themes that came up that we then were discussed in the following class. We as a class then got together in Zoom and then discussed. This was one that illustrates a theme that came up in a lot of the student ones, which was essentially possible dependence or addiction, because VR is, for various different stories, being in VR is more pleasant than interacting in real life. Another one, this one was interesting because this was about a feature of always on AR, and basically exploring the idea that so much of society is now using AR and it's always on, that people who don't have access to it are now disadvantaged. And then other themes that came up with were things like basically using VR as an outlet for being a bad actor, basically channeling all your negative and maybe violent tendencies into doing things in VR, and then sort of like living a dual life, essentially. So some of these got fantastical, but it was a way to extract themes. I went through all of them, presented them all to students, and then we discussed and extract and group them into themes that we could then discuss about the ethics of VR. So that was a really popular thing because for, as Blair mentioned, students were really starved to talk to one another. And so a lot of student comments were like, it was really great to like not have to like do another lecture, to be able to sort of just have a fun exercise and talk.
Yeah. Oh,
so that's
I was just gonna.
Go ahead.
I was going to add other things that you could do in this pandemic space with VR. Grace On, who's up at UGA with Kyle and a few other people, pulled me into doing this social journaling for the students. So we had every couple of weeks the students would submit a journal of we would require them to have a social VR experience with anyone. And sort of do it repeatedly over the semester and journal about their experiences using these technologies with other people, which the students found interesting. You know, it's like, gonna get mom in VR, which, you know, for some people is not a big deal. For other people, it's interesting. The other thing, and then I did a bunch of other kinds of meetings like that. Kyle's thing reminded me an assignment that I didn't do that I really wanted to do, which I would encourage other people to consider doing because I'd love to see someone do this, is have the students journal over the semester where their use of the technologies, where they used it, who was around, take pictures, and then use that at the end of the semester as the basis for an assignment like Kyle just described. I just ran out of time in the semester, so I decided not to do it. But I think that would be a really interesting way to ground some of the Black Mirror style stuff.
All right, so I want to note, I was hoping to leave about 15 minutes for questions, and somehow in a 3-hour tutorial, we nailed it to within 2 minutes. So that's pretty cool. I don't know how that happened. But please feel free to bring up questions, and happy to have more discussion. That is interesting, seeing in the Discord, Blair, that Hubs just released video-based avatars. I hadn't seen that.
Yeah, I mean, it's still the issue with so Hubs is interesting, and this actually will apply to, I think, a lot of VR systems, which is it's not necessarily the backend that's the problem right now. Like, you can build a big enough AWS server side that you can route content for 1,000 people. The problem is if you put on a Quest, right, that Quest has to render everything. So you need a non-dumb front end that's going to do some pretty aggressive management of what data they're trying to deal with. And things like Hubs and most systems don't manage that yet.
I do see a question we missed earlier about does the physics engine in Babylon allow for binaural audio simulation? I have no idea. I would probably say not, or you might have to do some work for that. I don't know.
So I guess, so when I think of binaural audio, I think of just playing back pre-recorded binaural audio, right? I mean, it supports stereo, but there's no, are you talking, when you say the physics system, like actually simulating the bouncing off walls and simulating in real time head shape and ears and all that. Whoever wrote that question. Oh, the latter. Yeah, I don't think do any systems support that yet in real time, aside from like high-end things targeting high-end gaming machines?
Yeah, not. I would not expect that to be something that this can do.
People are working on it, but it's a super hard problem to do well. So I mean, things like Unity and big game engines just do spatial subdivision to figure out how to cut off audio, but actually doing proper physics interaction. I mean, I've seen research over the years, but I haven't seen anything recently. What's the Unity Babylon package, Tom?
Yeah, I have not.
I admit the last time I installed Unity was version 3.52, of which I have 60 licenses, but I haven't used Unity in like 6 years.
I'm Googling it right now. It appears that there is a Babylon editor toolkit for Unity. And I will put a GitHub link on there.
Oh, it's an exporter to Webxr from Unity.
I just Googled it, and that's the link in the Discord. This was not on my radar. I was not aware that this existed.
Yeah. So is this essentially another attempt at getting Unity stuff on the web, in this case using Babylon? Okay. Yeah, that's cool, because the Webgl exporter, when I was at Mozilla, one of the MR team made a Webxr exporter for Unity, but it worked, so you can find it in the store. I don't know how I don't know, it probably hasn't been updated, but Unity's web export is not awesome still. It's pretty heavyweight, so it doesn't run on low-end machines, and so this might be a nice way around that.
Yeah, so it seems like it's been recently updated. So the Unity GLTF exporter that I use is basically for like the static scene and static meshes. It looks like this app actually supports animations, terrain, and navigation methods, collisions, box colliders, capital colliders, and things like that. So that's very interesting. That will definitely require a deeper deeper dive. But one of the interesting things about Babylon is that, you know, even like the last 6 months, there's new stuff. Like it's a very rapid, seems to be rapidly moving. I think there's other people who have mentioned, at least in the question, sorry, in Discord popped up, that there is a Webxr exporter for Unity. My lab actually, before we started using Babylon, tried to get that to work. It really did not work at the time that we used it. Perhaps I see that there have been updates within the last month, as recent as the last 20 days. So maybe there has been additional development, but back over the summer of last year, it was not functional to the point where we could use it.
Yeah, it didn't get updated by the person who had built it. The bigger problem is just the performance. It's not going to work well for lots of Unity. And I think the Babylon JS exporter is an interesting idea. The other problem with all these things is you're still in I'm developing in Unity. I have to use the Unity editor, and then I'm running a build cycle to export, right? So if you're using Unity and you want to get your stuff on the web, these are good solutions because you don't have to target devices. But for the point of teaching and so on, you still have the larger problem of, oh, you need to have a machine that runs Unity. You need, when you comes time to build, you have to run this thing which exports, and then you have to get it on the web, and then you have to do the debug. So you're losing all of that advantage. But it certainly is useful if you're tied into Unity for other reasons.
Yeah, one thing that I'm considering if we go back to an in-person modality in the fall, which is when I'm teaching the VR class again, is whether or not I want to include assignments with Babylon and some assignments with Unity, given that they can now have access to the computer labs again, and then have sort of like a section that shows here's how Webxr and Babylon work, and then a section that's like here's some stuff we're going to do in Unity, and then for their final projects, letting them choose the toolkit that they want to use.
Yeah,
that might be
yeah. I mean, I essentially did an assignment where they had to build the same program in. This was a long multi-part assignment. They had to build it in Babylon. They had to build it in Play Canvas, which was kind of like Unity. And then they had to build it in Play Canvas Engine again. And with the intent of having them really experience the difference of building with an object-based system versus building with an entity component style system, which Play Canvas is and which Unity is. And so I think it's a good idea because it lets you talk about the differences in architecture and why they're important and what they're, and then the students really experience what the difference is. That might be interesting, Rolf. I'm surprised there's not a very detailed Webxr course out there, but unfortunately, I'm not going to be teaching my class again for a while. They've pulled me into teaching ethics. I'm teaching ethics this semester and next spring.
Love has an interesting question. Love Coley, are there aspects of remote instruction that you've enjoyed that would not be possible with in-person instruction or vice versa? Teaching remotely sucks. I do think that one of the things that I appreciate about it, though, is that it has motivated me to think and innovate in the classroom in a way that I was not as motivated before. It was really easy to kind of like continue to teach the way I was teaching, which was fine. But I think I've made a lot of improvements to over the last year because of this. And because of that, I can carry that forward. Like students love having recorded live coding lectures. They love it. So even when I'm back in person, I'll do that again, just because it's great for students to be able to do that. And it cuts down on the amount of time in office hours, right? Because then I can just say, just watch the video where I explain this again, right? I don't need to walk you through it again if you can just watch the video and things like that. I also think the setting up the things like GitHub Classroom and I also use Slack. So my students can just like Slack a question and then I can just say, commit your code to GitHub and I check it out and then debug it and then talk to them is a lot more efficient as a way of just having this kind of cycle of helping students. So I would say those are the things that I enjoyed about teaching remotely, but they're more the fact they're not unique to teaching remotely because I can carry them forward into an in-person modality.
Yeah, for me, it's been interesting to experiment with different things, like all of the use of hubs for in-class experiences for a VR class was super nice because we wouldn't have done that in class, right? We actually did it the first semester where I got everybody to put on their Quest and we all were in the same hubs room. But, you know, the Wi-Fi at the university is kind of janky when everybody's in the same, essentially on the same hotspot because in the same classroom and you can't move around. And it's just, it was more of a gee whiz experience as opposed to really being remote and being immersed in that. So I really like that. This semester, I'm actually doing a lot more.
Don't worry about it in the front. Just go back.
Class stuff where I record lectures and then use my class time to just chat with students about other things. The students actually, it turns out, depending on the class, I'm teaching a required ethics class. So they actually really love not having to feel like they have to come to class because they can watch my slow lectures at double speed. So recording lectures is something I'll do more of for that reason. But there's still this FOMO where they feel like if they don't come to class, they're going to miss something, even if it's recorded. But if for material that can be adequately delivered as recorded, just not having it live releases the anxiety on the part of the students of feeling like they have to go and sit and listen to a lecture. So for the fall, I'm going to try to do some recorded lectures on 3D graphics. I'm teaching graphics, and then do a lot more in-class coding. But all of this stuff, like in class setting up your node, in class learning how to do all the mundane things like that some students will know and some students won't. Yeah,
Okay.
some students don't, but
I think we need to close because
okay. Ciao. Okay.
thank you.
Yep. Bye.
How's that?
Yeah, no, I can hear you. Hey, Susan.
Hey.
Hey.
Background is okay.
Yeah, crazy that they open the session just in the minute.
I know.
Yeah, yeah. But I've been listening to Player, interesting tutorial. Sure. Hello, welcome.
Rolf, can you do it?
Sure, sure. So I have to have a look on some notifications and let people in. How do I check, Susan, if they are allowed to?
I don't know.
Okay, by face.
Yeah, I don't know. We don't have like an attendee list or anything. So
Okay, we'll see.
Yeah.
Hopefully there will be nobody spamming the thing. Okay.
And then Evan, is that you? Who is on the line with us? IEEE host. Who are you? Yeah. Do you have a name?
Sure. Okay. The name in this
Joao. Okay.
in the Discord channel, I think we probably read. Yeah.
Okay.
Okay, so I will click on alle zulassen. Okay, here we go. Nice.
Hello.
Hello,
Hello.
everybody.
We're in.
Yeah,
This wasn't so easy. Now we're there.
Yeah.
Well, I'm glad we're all here now. And ethical best practices from combining the real and digital world. On behalf of all our great volunteers and partners who have done a fantastic job in preparing and organizing this event, it is my great honor and pleasure to welcome you to this IEEE VR 2021 tutorial on combining the virtual and the real, the open spatial computing platform. In this first session, the speakers will provide a big picture overview of the technology, concepts, and principles that have guided our organization in designing the reference open spatial computing platform, or as we say for convenience, the OSEP. We will also provide a quick overview on some of the client implementations that are available to you, as well as an overview of the schedule and resources available to you during this event. For OARC today, this is a major milestone, as this is the first time that we have made the fully operational implementation of the OSEP available to people outside of our organization. These are the first baby steps towards reaching out to a wider community of developers, academic researchers, and content creators, with what the OARC community has been working tirelessly towards for the last few years, even during the COVID pandemic. That has been a time of hardship also for many of in our community. We hope and believe that your participation this week will contribute towards bringing a future spatial web based on open standards and protocols a little bit closer to reality. I also hope that all of you who attend today and this week will have a good time, learn something of value, and be inspired to experiment and create something interesting that runs on this very new open platform. When it comes to the creation and development of AR experiences, Zap AR has been a world-class name for many years. For this reason, I am super proud and excited that Zap AR has decided to join us as our most recent partner. They have become famous for Zap AR, Creative Studio, and the ZapWork suite of award-winning SDKs, computer vision libraries, AR creator and content publishing tools, as well as the amazing Zapbox, their super affordable mixed reality kit that transforms your smartphone into a pair of AR glasses complete with hand controllers. Zap AR will also join us in our second tutorial session later today to tell you more about their technology, why they joined us, and how they hope to collaborate with us on the OSEP going forward. With that announcement out of the way, let's have a quick look at what the speakers in this session will talk about. First, Christine Perret, OARC board member and a driving force for AR interoperability and standards development, will talk about key concepts related to AR cloud technology. Then I will say a few words on the case for open standards and interoperability. Then Susan Oslin, our program manager for spatial experiences and also the main organizer of this event, will provide an overview of the tutorial schedule and some practical information. Then Vladimir Ufnarovsky, co-founder of Augmented City and coordinator of the testbed in Bari, Italy, will provide a high-level overview of the solutions provided by Augmented City for this tutorial. Last but not least, Mikko Karvonen, the Chief Product Officer of Immersal and coordinator of the Helsinki, Finland testbed, will give a high-level overview of the technologies provided by Immersal for this tutorial. After these presentations, we will be available for a live Q&A session. With that, I hand it over to Christine Perret.
Hello, my name is Christine Perret. I'm going to be running you through a few of the key AR cloud concepts that are inherent and very central to all that we'll be working on during this tutorial. First, I want to set the stage very largely. Ubiquitous computing has been around for a long, long time, and it's really the largest sphere in which we're speaking. Then there's another area called spatial computing, and I'll be talking and defining that for you. And then finally, setting AR cloud in the context of ubiquitous and spatial computing. So first of all, ubiquitous computing has been around for decades and decades, and really we're living this today. What we're talking about here is computers everywhere in our hands, in our lives, in the doors in our buildings, wherever we live, work, and play, and that they are intelligent in the sense that they are aware of our context and activities and have some insights about what we're going to do next. So just as a term, ubiquitous computing is something that it's seamless, it's integrated in all aspects of our lives. Now, spatial computing is different in that it relates to the 3D volumes around us and away from us. It encompasses perceptions also of space, space as it pertains to objects in the space and ourselves. And geospatial data is very important because it defines and is derived from these geospatially anchored places or spaces. So spatial computing changes the human relationship that people have with information. Before spatial computing, information was independent of the place. It was anywhere and everywhere. But with spatial computing, users are being attached and immersed in this 3D temporal data that's associated with the space that they're in or near. And so in this figure, you can see at the bottom, they're the bits, the atoms, not the bits, the atoms of the world. And then there are objects, and then these objects have relationships to one another. And then finally, the dimension of spatial computing in which humans have relationships to the spaces, the objects within those spaces. So with those two concepts, I'd like to now introduce world understanding. World understanding has to do with capturing the world and then using artificial intelligence, associating behaviors with these objects and places and activities. So here we have a tree. And of course, if we scan that tree in 3 dimensions, we'll see that there is a point cloud, and it clearly identifies the trunk is different from the roots, and the branches and the leaves are separate. But we recognize, or artificial intelligence recognizes, that this is a tree. And there might also be a bird flying in the sky, which is then scanned and understood to be a winged object, a bird, and that this bird has an affinity for sitting in the tree. And so in this way, I'm depicting for you this concept of world understanding, which is very, very important in AR Cloud. In all of these concepts, spatial data is really the very, very central to this topic. There are many different kinds of real world data and geometries. They describe the physical world in many, many dimensions continuously. So I like to use this idea of raw material as kind of like the liquid core of the earth, sort of everything that pertains to what we're doing now. So the data, the 3D and the temporal data about the physical world is all linked together, and it's near the user wherever that user is. And then with AR, we're used to thinking about there being an augmented reality presentation system that helps us to understand all the information that's about the physical world. So that part is very familiar to us. But now we're going to add that, in this presentation system, there's also an artificial intelligence component. There's an agent working on behalf of the user to help us make sense of the physical world and all the data, the raw data that is at the core. So this presentation system and all the intelligence is connecting, and there's a new layer, or a special layer now, because the amount of information at the core is almost infinite. It's so large that without this new layer in between, we couldn't understand it, we couldn't use it as effectively as we will with AR Cloud. So the first component of AR Cloud is that there is a series of systems that are helping to continuously and automatically discover information about the physical world as we're moving forward. And this word continuous is extremely important as it pertains to the fact that we're not stopping and starting applications with AR cloud technologies. In fact, we're causing the experience of the user to be enhanced all the way throughout their passage in space and time. So these are the next layer here. In order to enable all this artificial intelligence and the contextual search, we need some processing zones. Let's talk about those a little bit more deeply. First of all, they're not only on the device. The processing is being done in a variety of places. On the device for some information, and then also some edge cloud processing. And through this, we're able to distribute the resources and take some of the burden off of the display. And I think that there's a lot of history and a lot of merit in these layers of processing and the layers where different types of understanding are added or rendered. And so I like to inspire people with this industrial Internet of Things stack and think about that as we're moving forward. In fact, we can simplify it a little bit more for AR Cloud and say there are reality layers. There's a static reality layer that we can hold and process a little bit farther away from the user's device. And then there's the real-time reality layer that's changing much more quickly and has to be processed in the immediate and locally to the device. And so many things are being done either in the cloud or the edge, a lot of analysis and capture and storage. However, I also want to point out things that protect the privacy and the data and the freedom of individuals is most commonly done on the device. So now that we've looked at these different concepts of distributed computing and cloud and edge processing, let's see what's going on in that for the AR cloud. The first of that is reality capture. I mentioned it before, having to do with spatial computing. It's the continuous real-time capture of the world around the user. But then in addition to just capturing it, we have to map it, understand where it is with reference to the physical world and the user, and also the relationships between the spaces and the objects. So this requires contextual and semantic tagging, segmentation, and then tagging. And so through all of these embedded processes, we can more easily fuse the core data in this molten lava at the center of the universe to the physical world around the user, around people, places, and things in the physical world. So now with these concepts kind of setting the stage, I'd like to define for you what AR Cloud really means. It encompasses the creation, the management, and the use of this persistent, dynamic, and shareable machine-readable representation of place. Again, it's persistent, it's dynamic, it's being updated all the time, and two or more users can be sharing this 3D machine-readable representation of the physical world while they're having augmented reality experiences. So the capture, the creation, if you will, of this machine-readable world, and it has attributes that are being updated, maybe not just visual attributes, but temperature and vibrations, semantic information is being added. And this is connected, this information being captured by the device is being connected and stored in different places, as was discussed, in the cloud, on the edge of the network, using high performance, low latency network. So I've symbolized here some clouds, but also a tower, because we need 5G and very, very fast networks to connect all these resources to one another. Once those resources are working together, they're able to map, analyze, and query the spatial data, the spatial computing, and to help find the user, where are they in the physical, and what's immediately surrounding that user. Again, as the user moves in time and space and through the world in this continuous way, they can be prompted and offered different kinds of augmented reality experiences. There's recognition, of course, tracking, and all this live real-time processing happening, and together providing augmented reality experiences to the user. So to summarize, what constitutes an AR cloud product and service? What does that mean? Well, at the core of it is this data that's being continuously created, captured, and analyzed. It's being analyzed for mapping and indexing, and it's being done on and off the device. Remember, the edge and the cloud. That will allow us to do continuous localization, registration with the physical world, and to store information that we might need in the future. All that's being done in real time. So a lot of times people get curious about what kinds of information might there be that is either static or dynamic. And so the bottom part of this figure shows the real world. Remember at the beginning of spatial computing, I said that there were atoms. This is the physical reality. And then as we move up a little bit, there are bits that describe the machine readable representation of that physical world. There's the static layer that can be stored a little bit further away. There's the real-time dynamic layer that's always being updated. And then above that are what we call the thematic layers. And so those can be anything really, but they could help us find public transportation or find entertainment that meets our needs, or retail opportunities in the workplace, in our education, in our lives. So with AR Cloud, it's much, much more than just regular on-device augmented reality experiences. They are persistent. It's a continuous augmented reality world. There's the sharing of experiences that's much different. It's unlimited, and it can be for many users. And there is a special feature around device and user positioning. The technology that's used when you only have the device is limited to what's local and offline. The maps that are loaded on your device at this time. However, in contrast, with the AR Cloud, the device positioning is more diverse, and it's off device typically. It's continuous, it's geospatially anchored, and cloud-based. Often we talk about this as a positioning service. So to recap, there's the persistent cloud, the persistent world, and all of the data associated with it, stored in the edge or the cloud. There's this continuous augmented reality, so we have to break reality and the